We need to do another Tasmota day, because this mill light's been broken for some time now. I wonder if I can do like a rainy day cam. Burn the subs doesn't quite have the reach. It doesn't quite get to the window. So we can't really do a rainy day camera here. It'd be nice if I could. Rain doesn't really show up on cameras anyway. The droplets in puddles of water do, and for that I need elevation, and the ground is there. So, oh well. I just ate the most disappointing pizza I think I've ever had. I'm not ordering from that place again. That was just like generic. That was like office pizza. Office pizza. It's like the worst form of pizza ever invented. It's just grease and cheese and bread. There's nothing special or delicious about it. Really, really disappointing. At least I didn't eat a lot. And then I got fries with it. So it was like a $90 meal. French fries and a plain pizza. Getting a little ridiculous. I think I need to just go eat like wood chips or something. I don't know. We are gonna have to do a little bit of this stuff, but we're gonna have to actually follow a better example, I think is what we're gonna do. We're gonna move our class functions into a new thing. And I think we're following this example right here. But let me try to find, there's like it's like the Arduino example. So we'll just follow that. I'm just gonna make a class that's gonna do all the stuff we need to do with the timing and stuff like that. I mean, really, honestly, I could probably find an Arduino timing library that does these functions, but I don't want interrupts, and I need like, I don't know if I'll have the right stuff in the library. That's the reason why we're working with classes, and this is new to me. I've never done this before, so we took an entire stream yesterday to kind of rewrite some of the loops in the program so that they make a little bit more sense. But, oh man, we'll get there, we'll get there. My insulin prescription isn't gonna be filled until tomorrow. Nope.
Okay.
Ah, he's talking. He doesn't talk much.
It's a really good track, so I hope you guys like it. Another time.
No! Okay. It is a rainy day. It has been raining for 2 days. It is the flood. It is the great flood. We're all gonna die. All of our hedonistic ways are over. Yeah, it's been raining for like 2 days. I'm in the mood to program. Little sleepy, little wired. Where's my caffeine? Hold on, I need more caffeine. I need more caffeine in order to be able to code.
Thank you for those bits, and I appreciate all of you for your support.
This is Metronomic Live providing us with free music that we can listen to.
A lot of subs and resubs and people continuing their gift subs, and that's making this a good time. So I'll talk to you guys later.
I don't care how many viewers I have today. I'm just gonna get this done because we really need to get this stuff done, right? Make any sense of the class stuff? I didn't do any homework. I didn't read up on it until since yesterday. But I figure if we follow the example, we should be able to get stuff done. We should be able to put this stuff together and have something with multiple timers in it. And I don't know if we need to designate timers within the class. If we call the class multiple times in order to designate individual timers. I feel like that's what the button thing does. That or we find another timing library. If we can find a timing library, maybe we can just solve all this stuff. Let's just take a look. Delaying function calls, simple non-blocking timer library. In at every specified unit of time, supports millis, micros, rollover. Not really what I need. See, it's kind of hard to search for timing for libraries because of their library manager. They probably, in the newer IDE, it's probably easier, but I need to dedicate a little bit of time on my own to install the new IDE because I gotta move files around for it. Yeah, the native one is too basic. We need to actually invent one because the way that the BGM 111 module works is that the base station can request a timer, be set and repeat on an interval, and it can do that for 4 timers, I think 5. And we need to implement something like that so that our code will respond properly to these timers and just, you know, treat them appropriately. Because we're trying to emulate this thing, and so there's kind of like a keep awake signal. Where the hell's the library stuff? Sketch. Where's the library explorer? Manage libraries, there we go. Let's see what timing stuff exists out there. In the Improvosphere. Hey man. You can do it. Go. Time. Time. Search time. Multiple tasks? No. Although if we did a multiple task library, I guess we could just use a delay. You know, send packet, delay, send packet. I don't think I want to do that though. Ace button. Date, time zone class. No. Time clock. I really need to. I need a thing that flips my monitors around. Because I can't just change you guys around because then OBS won't get it. But I need to be looking this way when I'm doing programming stuff. I need to have a programming specific layout. But I don't want to do a programming overlay because then I'll accidentally click it and you guys will be able to see my whole dashboard, which doesn't really have any doxing information on it, but you could see how abysmally slow my pre-stream chat is on Saturdays. Listen, we'll get back to Saturdays being for the boys. Not really the boys, just whoever. You guys can, whatever you identify as, I don't care. We'll get back to Saturdays being for games. We'll get back to that. I've sunk my teeth too deep into this project and I want to finish it. What'd you find? Arduino-timer? Is it like a little egg timer? Non-blocking timer library for calling functions in at every specified unit of time. But does it interrupt? 10 concurrent tasks. Yeah, this might be what we're looking for. I think this is essentially what I was trying to build. I'm gonna blow the text size up so that I can read it on the OBS. See, make a function to call when a timer expires. So that would be interrupting. So if I'm transmitting, hold on. If I'm transmitting on-demand serial, I guess I could do serial dot. Well, no, it would always be available for transmit. I guess if I'm already receiving. Cancel task. There's no active tasks. Number of active tasks? Jesus Christ. I don't know. I mean, this could possibly be used, or we could continue to make our own call. Yeah, I mean, that's kind of... That might be the minimal implementation of what we're talking about here, because I don't know if they set any timers that are not reoccurring.
Yeah,
Who's talking? Who's talking? Ghosts! I have ghosts! Avoid the ticks calculation. What? I mean, what I could do is I could have the interruption tasks of the timer set a flag, and then that would, the flag would then go off in sequence with everything else. So we'd finish whatever we're doing, and then do the rest of the stuff, because it's going to interrupt and perform its function could just be set the Boolean to 1. It just fires once when the set delay expires, and so then we'd have to check our reoccurring variable, etc., etc. We need maybe a variable array, and then we could check which ones are reoccurring, and then reset them to whatever time that they've been set to. And then that one function would then print the OK depending on the timer, and then reset the expired flag. So we need expire flag, we need a previous time flag for all of them, however many there may be. Ugh. Ugh. I don't know. Does this clean up our code? I mean, this makes our code a lot easier. But it's not as, like, scalable. Like, if they try to call more than 2 timers, we have to modify our code. Example? I'll look. Consider becoming a sponsor. What are you talking about? Auto timer. Create default timer with the, is this the one you're talking about? I think it is. Bool, toggle LED, digital write, built-in LED. Return true, setup pin mode, built-in output. We might need to make a test program. We might need to do that. I might need to spin off another program and do a little test so that we can see how we can manipulate this timer. Maybe we could just use the library. So all this is doing in the loop is ticking the timer. And then where's our function? Timer every 1000, toggle LED. Ah, and then toggle LED is a return bool, which I don't know if it has to be, and then you call it as a void, and then this is the function, and you return to keep the timer active. Ah, this actually might be exactly what we need. So how would you do multiple timers? Oh, I don't need to know the instructions. Timer task, every unsigned long, unsigned long, unsigned long delay. I think they have an example of multiples, right? I think we just have to call timer, timer 1, timer 2, timer 3. Ay, okay. All right. Yeah, maybe we use it. Maybe use somebody else's library. Hold on. Excuse me. How would we work that?
Okay, guys. We're gonna bring it back up to speed. I need to. Well, if you guys don't mind, I'm just gonna do like a hard break, and we're gonna go like.
As far as I can work out, you just set up one timer with the number of task slots you want. Yeah, so I can't do multiple timers on this. Ten concurrent tasks. I mean, like, the number of concurrent tasks is just whatever you put inside of your function, right? Timer 10, micros, int, the handler argument type int. Excuse me. That's the number of slots in the timer. Ah. So we would have, I mean, if we wanted to truly emulate the BGM 111, we'd say timer 5. We don't need 5 timers. I mean, we could have timer 2. But I don't know how to handle the ID of the timer and stuff. They can expire at different times, but then which one, we don't know. Do we know which one is expiring? Timer in, delay, function to call, argument. Optional argument for the function to call. Aha! So we give it an argument. So the ID would be the argument. So it'd be timer, function to call, argument is 2. And if the argument's 2, then we kick back, hey, timer 2 is expired. And then we can have a check in there that says, is timer 2 reoccurring? If so, set this, set that. Yeah, base it on the function call or pass it an argument. So it depends. Timer in delay, and then the different delays can call different functions. Aha, okay, all right. I get it now. So okay, this is actually what we'll use then. This'll do. Hold on, I have to come back from the dream realm. Okay, I'm back. This song is awesome, by the way. What was this called? Or is it even on thing? Arduino-timer? I don't think that's gonna... I think I may need to install this one on my own. Who made this? Contrem. I don't know if he's on here. Yeah, so we'll have to just do it from a zip file. Yeah, we'll just use the argument, and we'll just feed it an int, and that way we can check to see how many timers are going, and we can just start a new one. And when we end one, well, that's going to be a little bit different when we end one, because I think it does send a command to end a timer, so we'll have to be able to unset a timer. I'm not sure how we're going to do that, but we'll figure that out. I mean, I can just set 2 timers for now, and then I can set it up so that it'll print out any additional timers that try to get set, so that we can see them in the serial readout. We can cater to them. We can just very specifically cater the software to the boot up sequence and get it into functioning mode. That's the goal. I just don't like installing libraries like this because then it doesn't translate over to the other IDE. I have to go find it again. So let me put this in the comments, just so I'm sure where to get everything before I even include it. That'll help us get through this. You can cancel the running timer. Well, it'll be more like, yeah, I guess so. I guess we're not gonna reset it when it transmits. It'll transmit, and then we'll see whether or not we cancel the timer at that point. That's how we'll have to do it. All right, I have to use the bathroom. You ever get that thing on the weekends where you like, I mean, it might be caffeine related, but for me, it's like when I just start working on projects, I start moving around, and your body's like, nope, we're gonna have to deal with some stuff first. So I'll be right back. Overlays? That's an overshare, but but I'm streaming. Apparently you guys are privy to every piece of information that crosses my path. So yeah, we'll get started in just a minute here. I have got good ideas now. Trade Splatters helped me come up with some stuff here, a nice library for us to use. We'll see what we can do with that. That way we don't have to make our own class and do weird stuff. Although I did like my weird stuff. I liked my weird stuff. But this will just take a little bit of the burden off of my hands, right? And then we can either build a program to try to perform these functions, or we can just try to go all in and see what happens. I'll be right back though.
7, 6,
Actually, the mix is getting kind of sour here. I'm gonna back it way up. I'm gonna back it way up so it's nice and chill. There is a portion right here, but I don't think it's gonna take me an hour and 36 minutes to get back. I'll be back in like 5 minutes. We'll be good. Here, beep. I'm disappointed we didn't get any follow bots while I was gone. All right, what the hell is he doing online? Ravaz, what are you doing, man? Oh, he can't stop playing that Warhammer game. All right, let's get going. Let's start programming, huh? I said I'd program, I'm gonna program. We're gonna program for a long time today. I'll see where I get to with this thing, and I appreciate you guys hanging out for this whole process, but this is something that I need to get done, right? So we're gonna try to get this done. So Trade Splatter found this library, GitHub Contrem Arduino-timer. This will allow us to run multiple timers on this thing. What we'll be able to do is run timer 1, timer 2, timer 3, etc. And I guess we need to store the timer ID as a variable and then call upon it if it's set. This is going to be a little weird and complicated, and I'm going to have to try to put this together. We're going to assume 2 timers for the moment, and if we get any timer ID that is not represented, then we'll have to print out what the timer ID is. All right. Hey, thank you for the follow. So we'll have to print out what the timer ID is. What we're trying to do, and I'll explain it real briefly, try to keep it quick. We're trying to push buttons on my simulator setup. It's a Simucube, a Granite device's Simucube. Previously, we have a microcontroller sitting here with a port expander on it that's flipping 1s and 0s into the limited number of inputs to the device to make it seem like we're flipping switches. What we need to do is we need to turn this over to a digital system. Granite Devices has a wireless wheel module that connects via a BGM111 low-energy Bluetooth over TX and RX. What we've done is we've looked up the data sheet of the module and we found out the entire API of the thing. So we are able to do communication. So we need to make a device that's eventually going to be that will plug into that TX and RX and emulate the serial signal. So the base station gives commands to the module and the module responds in kind. In addition to that, it has a special packet that it uses to tell the base station that buttons have been pressed and unpressed, and it has like a timer. It has a couple timers on it. So what we're trying to do is we're trying to get through the boot sequence where the simulator base station is configuring the module, and then it runs those, it responds to the timer. So we want to get to that point, and then we can start injecting our button press packets. All of this just to push a couple extra buttons, but I mean, it's been a pretty worthwhile project. I've had a lot of fun doing the reverse engineering on this thing, and I got to kind of I got to flex a little bit. I got to do a little bit of this just to show you guys a little bit of the reverse engineering mindset and how to go about that. Because they don't teach you this in school. Maybe some schools have a reverse engineering program, but generally reverse engineering is becoming a fast expert on the technology that you're looking at and then breaking it down part by part, and then suddenly discovering that there are all these resources that you could have called upon. Generally, 9 times out of 10, and it's like 98 times out of 100, the engineer will just follow whatever's in the data sheet. There's no need to rock the boat. You look up the product that you want to use. You say, wow, this thing is really good at regulating voltage. What do I need to run? And it says, oh, you need this, that, this, and the other thing. You go, all right, let me just do that. I'll just do whatever circuit you have in the data sheet. Boom, now we got a voltage regulator. They work in kind of a systems engineering approach in electronics where you have blocks of things doing stuff. Every now and then, there is a design requirement. For instance, oh, those capacitors are too big. Let's put a bunch of smaller capacitors on it. Generally, that's it. So bother, how do you know so much about everything? I take stuff apart and I look at how people build it and I really get into the weeds. I get all the way down to the data sheet and I look at what's going on, trace by trace, and then you discover these kinds of things. So that's where we are. That's what we did with this. We kind of figured out but 1 by 0 in order to figure out what exactly this thing is saying. So now we have the whole thing categorized, and just in time, because I broke the transmitter. I broke it. I hooked it up to too much battery. So it's fucking dead. It's fucking dead. It'll never be the same again. Here's what we can do. There's 2 things we can do with the scheme here. Well, you know what? Let's worry about that later. What we're worried about right now is we want to get to the point where we're sending a periodic timer signal and the module has basically done the initial configuration, right? So what we've done is we've set up a program that is capable of doing serial communication with the module. And we've set up the packets that we see communicating that we can repeat and send back to the base station. And that's what all this is. All this is identifying and replying to packets. One second, hiccup and burp. Chat, I had the most disappointing pizza for lunch. It was like the office special pizza. Like, I wouldn't wish it on my enemies. It was bad. It was like, it's not that it was like so bad that it was unpalatable. It's more like it was just, I don't know. It's just like not good, you know? I paid like $40 for the pizza and a thing of French fries, and they were both like, I could have done better with an oven pizza. Maybe I should do that in the future. I should go to the freezer section. Those usually have an inordinate number of carbs in them, though. They're ridiculous. So I don't know what to do about pizza. Pizza around here sucks. You might be able to get a good cheesesteak if you splurge, but I don't know. Yeah, maybe I'm just relegated back to cold cuts. I'll just make a sandwich. Anyway, disappointing pizza that's making me burp aside. What we have here is a categorization of all the packets. We got that from the datasheet. One sec. We got that from the BGM 111 module. Turns out it has a comprehensive API. The API is the Advanced Programming Interface. It's just what you use in order to talk to this thing, right? It has a specific packet structure, which boggled some of the programmers out there. I see SC83 said something earlier. Yeah, SC83 and I were discussing the packet in previous streams, and we were both wrong. We were both so wrong. We were both so wrong. Just made chili cheese fries. That sounds good. Wish I had chili cheese on hand, just like in the can, because you know that's good stuff. Just nacho cheese in the can. Yeah, I want it. I just scoop it with my hand and eat it. I don't do that. I don't do that. That would I'd puke. All right. Anyway, so the API is comprehensive, so we know exactly how to communicate with this thing. So all we need to do is emulate this thing in order to push buttons. Now, obviously, you know, hey, I could probably get a BGM 111 like development kit and just make something that does all these tasks for us and still be the BGM 111. So it'd have all these timers built in. But I'm not made of money, and I already spent $100. $100 on the transmitter and receiver from a British UK motorsports company. It's because Granite doesn't sell them directly. $100. Have collected my pizza and I'm ready to backseat. Yeah, my pizza took forever to get here and it was immensely disappointing. I don't think any amount of garlic and pepper and anything can save it. I should have gotten a special one. I should have gotten like a buffalo chicken pizza. That would have been probably a little better. But like this pizza place is like mediocre and they're charging fancy pizza place prices. I don't think I'm going back to them. They're real close by and I like supporting them, but nope. And I will never buy Pizza Hut or Papa John's or anything like that. I don't do that. Always support the local pizzerias, especially in the Northeast where there's always one within a stone's throw. Always. Even if they suck. There's actually a place by here that makes probably... Yep, they make that. That's what they make. They probably make one of the better pizzas and cheesesteaks that I've ever had, but they don't deliver. So I think maybe I just need to figure out the best way to get there and just go there from now on. They're very, very good. I'll have to like Google them and stuff because I'm sick of the delivery options. Fucking suburbs. All right. Anyway, we got a couple things that we need to do. Keep up time is not something that we even use anymore. The conversion factor we do need because this thing works in ticks and we work in milliseconds. Hold on. Build a robot to get it for you so it can like fall in a gutter. Just go there and then they suck and you like it. What? Oh, and tell them that they suck. What? It still doesn't make much sense, man. All right, so we need a library. I was gonna make a class. I was gonna make an entire class. Look at all this code. Look at all this code. We still need this. So I'm gonna take this. Actually, I'm gonna take all this because we need all this. We can redo all of this. Let me start like a notepad. I've already got a notepad notes sheet, but I'll put some new lines in it. Your pizza sucks. Prove me wrong. I already said it sucks. I already said that. I literally gave you all that information and you're just regurgitating it at me. What does that even prove? What are you doing? Tired of seeing the ad for Mod Pizza. It makes me never want to get from there because I'm sick. I don't even know what it is. All I get is that shitty DoorDash. Oh, say that to them. Why would I want to say that to them, though? Their pizza's good. I don't want them to do anything different. I don't, look, the pizza without spit in it is great. Why do you want to get spit in my pizza? All right, I'm just going to take this stuff just to remind me of what's going on. We'll just blow away this entire thing, right? And we don't need last time anymore because we've got our own event-based timer going on. So that's the packet getting stuff. Whenever we get a packet, what we do is we throw most of the packet into the buffer, but then the ID, the type, the length, and the it's like the class are all stored as their own bytes. So when we try to extract stuff from the packet, we got to remember that those are there. So if I try to print out a packet that we don't know, then I'll have to print all of that out. We have a function that does that. It should reliably do that. You see, the big hurdles in this project, well, the largest hurdle in this project is me explaining the project over and over again so that I'm on the level of the majority of people watching. I'm trying to keep you guys up with me, and it slows down the process a lot. And I know people like to see much more progress out of their streamers, but your intrepid streamer is in way over the complexity level that he typically allows on the stream. And that's affecting it. So you guys should know that. It takes a while when we get into the really complicated stuff, and we are in the weeds. We are in the tall grass, folks, and there are Pokemon on there. We are basically implementing something that fakes a module into thinking that we are something else. And then we're going to take over that and be able to use that to our advantage. So we got to think about a lot of stuff at the same time. In addition to that, we don't have everything captured. We have most of the things captured. So we need to think about what's going to happen when this fails. We need to be able to tell ourselves what's going on so that we can cater to it. So if anybody needs to know what we're doing today, they can flip the stream all the way back until I get back from BRB. And from there out, it's about a 10-minute explanation of absolutely everything that's going on. So TradeSplatter found this thing just when we were talking ahead of the show. We have a library that's going to allow us to set off events, and I can set off up to 10 events. And my fly's down. All right, my fly's up. We can set up to 10 events. Now, the BGM 1,011,011, I don't know how many ones there are. There's a lot of ones. The BGM can set up to 5 timers. So we've got up to 10. So I think we'll be able to do it. What's up, TurboNad? How you doing, man? I'm desperately trying to get something done today after my disappointing pizza. And it's been raining for 2 days, which practically makes me British. So let's try to get to this thing, man. So, all right, first things first, I need to include this library in here. And I don't think it's in the library manager. I looked around for it. So instead, I am going to go to the same sketch thing. This is the old IDE. I need to install the new IDE, and I'll do that. It's just going to take an entire day of thought that I just don't have. I don't have that bandwidth right now. That's my new favorite thing to say. We're going to, well, first of all, on the desktop, I have a shortcut. This isn't the desktop. There's the desktop. I have a stream shortcut. Oh no, but we're not going there. We're going to downloads. Are downloads available from here? No. Downloads. Oh my God. View details. Date modified. Other way around. There it is. Arduino-timer master.zip. Yeah, yep. That's what's kept me a little reluctant. Okay, I guess it installed. Most of my sketches are kept off-site. They're kept in the what do you call it? They're kept in the file server, which now I have a generator on this property, which was not cheap. That's like, I'm going to be paying that for a while. But now that I have a generator and all the battery backups, what it means that if power goes out here, the only thing that'll stop stream is when the network fails, which is like 10, 15 minutes. Hopefully, I would hope the network lasts a little longer. And I'm not talking about the network in this house. Network in this house has a battery on it. So it'll be completely seamless going from regular power to generator, but then I have to end stream when the internet goes out now. So it's no longer my fault. It's no longer my fault. Natural gas will keep us running during a power outage. I'm looking forward to that day because that'll be kind of funny. But I don't know. Pico's been a lot better. I think they cleared a lot of shrubbery that's been around wires. So we haven't had any power outages this year. You know, cross my heart, hope to die. Stick a needle in your eye. Anyway. All right. So we got this GitHub Contrem Arduino timer. Let's take a look at the examples in there and see how this thing functions. So I'm hoping with the new IDE, the new Arduino IDE, I'll actually be able to see my cursor when I hover over. I don't think this is an Arduino problem, the cursor not changing colors on OBS. And like on my desktop, the cursor's white and I can see it. On OBS, it's not. I don't know how that, I don't know what's going on there. See, the little fingery pokey thing is fine. I can see that. Because if we're gonna co-witness so that I can look over like this, it doesn't look, I can't see where my cursor is, and that kind of hurts my ability to function. What I need to set up the Stream Deck so that I can flip my monitors. I don't know how to do that. I don't know if there's a plugin that I need to get. I wanna just flip the two monitors, and that way I'm looking up here and chat's down there. Because most of my thumbnails when I'm programming chat, are me like looking, like that's my programming face, and I don't like it. I don't like it one bit, not one bit. All right, let's see. Anyway, what would it be? Sketch, include library. Let's see where it is. Let's see if it installed correctly. Old Windows 98 animated cursors. Oh my God, I should turn Trails on. X10? No. Time alarms, timer 1, timer 3. What? Talkie? No. Oh, I guess there's a Teensy Threads library. Responsive analog read is one of my favorite underground libraries. That's kind of like probably pretty depreciated, but responsive analog read is really, really useful. And this applies to you, TurboNad, among other people here who are interested in sim setups and doing your own custom Arduino or Teensy to USB interfaces. Responsive analog read is one of the best. What it does, this has been like the secret to the Oh Bother controller for many, many years. What it does is it uses Cayman filtering. And Cayman filtering is a complicated control system filtering that you can run on very low power systems if you do all the math. And what it's able to do is it's able to stabilize your analog read and in the dead area, and then immediately push it over to a point when you push the stick to a point, and it'll filter out a lot of the noise that the Arduino typically receives on its analogs. Analogs on the Arduino can be very noisy, and this thing can really, really help. So, and it'll also help you scale and do all that stuff. It's a really good library. It'll just run kind of in the background. You won't really notice it. My computer's doing some weird stuff. I've noticed a couple little stumbles. I'm not dropping frames. Weird. Bother's programming face. God damn it. I guess the bit was good enough to garner a clip. It's fine. It's fine. I don't have any integrity. Thank you for following. HX711. I mean, this thing is like Arduino dash timer. Is that how it's going to come through on this? I don't even know where this library is. Did it even install? You know, the thing with typically these downloads, is that I think maybe I need to extract it into a folder, and then I don't know. I don't know if install from zip is gonna. Hold on, Arduino dash time alarms. That's not the one. What about time? Well, let's look at the examples. Where was it? Was here we go. Blah 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 blah. Where did time go? Where'd all the time go, chat? Where'd it go? Talkie, teensy, time. Sync Arduino clock, NTP. No, that's not the right one. Okay. Time alarms. .pde. I don't think this is the right one. Yeah, that's not right. I don't think it installed properly. Baloo, thank you for the 100 bitums. I appreciate that, man. How's it going? Yeah, I'm figuring out how to do a little Arduino stuff today. We're gonna install this library that should hopefully guide us through multiple timers. But we need to basically set a timer, and we need to set some properties for the timer and figure out how we can set multiples with different IDs. That's the difficult part here. It may mean that we need multiple variables, multiple bytes in order to store the timer IDs that we get. And if we get anything that's not 0 or 2, which we don't have a lot of examples of timers, it looks like it might only set up one timer. But we'll set it up for 2, and if we get anything other than 2, we'll print out the command and we'll figure out what's going on. We needed to be able to unset the timer, set the timer, check to see whether or not it's reciprocating. Where the hell am I going? Download folder. I'm trying to install the library. Extract it to there. That's what I thought, motherfucker. It's always a folder in a folder, and that always makes the IDE like, I don't know what's going on. That should have installed, though. Wait, what is he calling it again? Arduino-timer. Ah! Okay. Arduino-timer. Why didn't it install? Look for anything that starts with an A. All the way to the top. 80. No, I didn't want 80C. Get out of here. Get out of here. So it is just raining outside, which makes it a perfect day to do something like this. I need a camera on the outside, but my the board camera doesn't quite reach. Hey Pyro, how's it going? Arduino-timer. We're installing a library. So I'm looking for what happened to that. I have so much stuff installed here. Wait, it only goes down to there? Okay. Arduino-timer. And there's time alarms, timer 1, timer 3, but those aren't the right ones. It said it installed. You lied to me. All right, let's try again then. Arduino IRC, WebSockets, ArtNet, yeah. Adafruit, accelerator. It was near the bottom? That would make sense. What did it just do? Ah! What is all this? What have you done? We're not using fast LED. It's like, here's 5,000 things. Sketch, library, towards the bottom. There it is. Hey, Arduino-timer. All right, so we're including Arduino-timer, and this is somebody else's. Yeah, it was lowercase a. That's so weird. So all the uppercases come for. All right, whatever. This is just somebody's GitHub library. I guess they never managed to register it with Arduino or however you get your code listed in the library manager. So we're installing it directly from GitHub, and it apparently installed, which is nice. I didn't have to extract that zip that I just did. What a waste. But anyway, we've got this library installed. How are we going to use it? Well, I don't know. Let's get going. Let's see if we can figure this out. Let us begin. So I need to look at an example, which all libraries are supposed to come with an example. So I should be able to go to File, which, by the way, Sketch folder has the install library. File folder has the example. I don't know. The organization of the old IDE is crazy. I'm gonna have to go to the new one. So all the way towards the bottom. Lowercase. No? Tell me there are examples. It doesn't look like there are examples. No, there it is. In this menu, it doesn't do capitals and then lower cases. It just does first letter. Because of course you do that. Why not? Why wouldn't you? Why would you do it the other way? Oh, but the other menu does it the other way. Ah, the Arduino IDE. Tests. I don't care about rollover. Unit tests. Blink micros. Okay, so we've got a couple examples, and I don't think there's a multiple timer test example. We'll see. I'm opening up timer test. If it opens, oh, there it is. So what do we get in timer test? What the hell? Unix host Arduino. What is it? Okay. It's not picked up for free by Arduino. What the fuck is... All right. Nope. Nope. Yeah, if they, they both fixed their menu. Like 2 different people are responsible for the 2 different menus, and they, of course, both fix their problem and don't coordinate with each other. All right, so just regular old Blink example. RYG, hey, thank you for the 12 months. 12 months at tier 1. I really appreciate you coming out here and putting yourself forward in order to subscribe for an entire year. That's very nice of you. arduino-timer.h, right? So timer create default. That's a default timer, default settings. We're not obviously going to do that. It's when we get a certain packet that we need to then create a timer. But again, this is just their example, and we'll just kind of think about it within context of how we're going to use this. So toggle LED. This is the function that runs, and I guess it returns a bool. I don't know why we need to return a boolean from this function, because I mean, when are they running it? Setup, pin mode, LED pin out, timer every. So here's the setup. So this is the function that we will run when we want to trigger a specific function. And we can either trigger a specific function, or we can trigger a function and then give it a specific ID, or an argument. We can pass an argument into the function if we want to. And then when we loop, we just tick the timer. And so tick the timer just updates everything. Update, update, update. And if it updates and it triggers something, it'll go to that function and then come back. So how are we going to do this within context of the timers that we're setting up? Well, so far, we only really see the ID of 2. But we could set up multiple timers with multiple IDs. Hold on. We can set up multiple timers with multiple IDs up to 10, or just 1 with a function, although that timer time has to differ from timer to timer. So I guess what we'll do, I wonder if we do the function is repeat or not repeat. I think the function is repeat or not repeat. Because if it's not repeat, then we need to undo the timer that we just set. Which means, how do we do multiple timers then? Timer every 1000 does this function. Timer of a different ID does this many, and then repeat. Okay, it's starting to come together in my head. I don't know if you guys are following along with what I'm doing, because I'm sort of flexing the brain meats and just thinking about exactly how I'm going to put together this function. I don't quite understand it all yet. There's some features of this timer that I think I need to investigate a little bit more. We're not gonna, we don't want to bog this thing down in long functions, right? Because if we're in the middle of sending something, if we're in the middle of sending a button packet and the timer expires, we don't want it to interrupt. We want to finish sending the button packet and then send our other things. We're gonna set up Boolean flags for everything that needs to happen here. Man, oh man. 1 year later, and I still have no idea what's going on. There have been portions of the stream that have been simpler. I argue to myself, mostly. All right, so our function here is to first set everything up. So we need to include timer 8h auto. Wow, that's a weird one. Timer create default. Create a timer with default settings. What does that mean? I think we can just do default settings then. I don't know if we need to alter the settings. So that's sometime after the conversion. So let's just do like, let's just put a little timer library section. So we'll do timer, we'll just call it timer. We'll do what they do in the example. Because our function is what's really gonna make it differ from each other. So when, and for some reason we're void star on that one. So auto timer, timer default, and then bool, that would be like time over, something like that. Should we do like, the timer is over at a certain interval. If we set up another timer that runs the same function, but it gives it a different variable. So we would have a byte. Now, okay, so would we reference to the byte with the star? Is that what we want to do there? I think that may be what we want to do. So I would want byte star. This would be, I don't know, time expired. And that byte is going to be the timer ID. Is that correct? Is that the way? I mean, we can have concurrent timers. We can have up to 10. So when that ID expires, then what we need to do is we need to set up, we don't need to push the byte into there, do we? Well, we should, because we need to set up, so, okay, this is interrupting though. This is what we would, let's set it up to interrupt first, because perhaps we can, then we need a transmitted flag. We need a flag on the thing that we're sending to make sure that we sent it. Because then we go back to transmitting and we could potentially leave buttons in the wrong states. This would be, what I'm thinking about is what happens when functions collide. When functions collide! Then again, we're running the tick update periodically. So we would go automatically from the tick update to this. So it actually doesn't interfere with anything. Yeah, this actually doesn't interfere with anything. So we could just put our full functions in here. Okay. So that means that we would set timer response of 5 is equal of 4 because it's 5 is equal to and it would be whatever we pass in. I can just reassign it. Byte input, or no, timer number. Just like that. So then that would go through there. Return true. Repeat is equal to true. So if this returns false, then repeat is equal to false. Wait, so I could just set that up to be directly the thing. What happens when it returns false? That's not covered anywhere in the example. Hold on a minute. Wait a minute. So that stops the time. Oh, that's super convenient. That's really going to clean up our code. Yeah, so if you run it as .every, but if it returns false, then so I can just set up a timer. So bool timer revengeance, remember that's what we called it, is equal to 0, and this one and it actually has to run the opposite way. 1 if repeat. No. 1 0 if repeat. How do we store that data? How do we store that data? Because we're going to have... Ah, damn it. Because when we set that, we will be resetting the packet and stuff. So if we get a timer ID of 0 to 5, we can put it in an array, and then we can address the array based on the ID number. Let me think about this, because, like, how are we going to do that? I mean, I'd have to have something that kind of iterates through arrays then, which is annoying. We're lucky though that this isn't going to interfere with anything. It's just wherever we set our timer to update. Why are you guys following me? Thank you for the follows. I don't understand it. I'm not doing anything. This is dumb. You guys should think I'm dumb. Sorry. No, thank you for the follows. I appreciate it. So what we're trying to do is set it so that our base station can assign timers, right? And it can set and unset timers if it feels like it as well. If we get a timer that equals 0, 0, we're going to have to unset a timer. We're not there yet. What we're trying to ascertain is how we run multiple timers with multiple expirations. And so what it allows you to do is run a function, but it lets you also run a function with an argument in it. So if the argument is the byte that equals the timer number, then we can send back the packet that says, hey, timer number has expired, right? We can automatically do that. And so now we need to handle whether or not the timer is repeating, and we need to handle that based on the ID. But we also need to be able to expire the timer. So if the timer is set not to repeat, we can do a different return. We need to know whether or not we need to do that return. And we only have one argument to put in there. So if we only have one argument to put in there, then we need a way to store that setting. So I need either a bunch of bools, and we need to just figure out which Boolean corresponds to which timer, which is annoying because this would have been fully functional. Or I don't know. I mean, if we have, I could store the timer number and the repeat as a character or two, yeah, it wouldn't be byte. It would be uint16t. Here's what we got to do. We'll put them both together. So now we know whether or not it's repeating, although it doesn't need to be the full thing. So uint, well, if it's going to be larger than a uint8t, although we could probably store 0 through 5, and then we could store 0 and 1. That's a uint8t. So the timer number is going to be a little bit of a weird thing. So what we can do is we can shift timer number over 1 byte, and then that'll be the timer number. But then we'll need to store it in a weird way too. If we shift it 4 to the right or the left, which direction are we going? Hold on, wait a minute. How are you storing this thing? We got to get this right. It's all bit stuff, right? Because we can store it as byte, because there's only going to be up to 10 timers, and 4 bytes gets you up to like 9. No, it gets you past that. It gets you to F. So yeah, that's what I'm talking about right now, Trade. Yeah, exactly. Because we'll have that timer just stored as its own thing. So it'll be a complete what's it, and then based on the ID and the repeat setting that it sends us. Things are getting weird, chat. I may just use some of the byte functions because they're a little bit more clear to me. I mean, if I shift it to the right, does it replace it with Fs or not? I don't see. These are the questions that I don't know the answers to. Documentation, reference, and then there's some bits and byte function. High byte, low byte, bit right, bit set. Okay. If you have a read loop where you parse out the starting and stopping of times, you can trigger and stop everything from there. Well, I think I like the way that I'm doing it. I just need to make sure that I extract the right numbers from everything. So if there's that delay again. I'm getting like, I should probably have restarted OBS before I started today. Oh well, how much memory do I have on the hard drive? Maybe that's the problem. Now we have enough for a couple more streams before I have to do the copy over. I don't know. It's just OBS gets a little weird if it's been running for too long. All right. So our timer ID And we're going to get all this information, and then that 5th byte is going to need to change into timer number. Timer number, so I need, like, get the MSB or the LSB from character. Yeah, so I'm doing it right. So if I shift it over by 4, because it's 8, then we get that first number, the first hexadecimal number. And if we do it the other direction, do we get the second one? See, I can't tell if I'm going in the right direction. This stuff is all so confusing. Or apply a bit mask. That would be one way to do it. We can just try it and see how it breaks. That is one way to do it. Nth indexing from 0, you left shift it. So do we want to shift it to the, like, we don't, no. I still need, I mean, I could put a mask over it, but I can shift it 4 this way, and then if timer number shift left 4 is equal to 0x00. If it's equal to 0, return false. 0. I like to use 0 and 1 instead of this. Else. Return true. Assuming that I got the bit math right, which is a big assumption right there. That is a big assumption right there. If it returns a 1... No, wait a minute. If it returns a 1, it stops. No. It returns true. That means it repeats. So if it is 0, it should stop. If it's a 1, no, it's the other way around. Ah! My brain! Now, I could just say timer number shifted 4, and then that'll be a 1 or a 0, and that'll be a true or false anyway, but I'll just put that in there. I'll put the comparison in there. I don't know if that's, if we shift it 4 that way, that's not going to be a 1. If timer number, I think I need a bit mask. I think I need to bit mask it. I need to mask the part that I'm not using, because in the 1, I need to shift it over. Shouldn't I be shifting it over the other way, though? Chat, I'm confused about bit math. Does anybody out there know about bit math? I take your silence to mean no. All right. I'll look for it. I'll look to see what's going on. See, I'm not trying to set anything. I just want to see what it is. I want to use it as comparison. This is just for the entirely significant bit. They're looking at bits. I'm looking at like the high and low byte, which would be the I could probably use a function to do that, and it'll just kind of clear it up in my head. I'll just leave it to the people who know what high byte and low byte, how to operate them. Byte, bit byte. This is a part of the other problem, is that I can't keep this straight in my head. Wait, what does the 4 mean then? A word is 2 bytes. A byte is 8 bits. We need, like, the nibble. We need the nibble. Get nibble from byte Arduino. There, that's what we need. I was gonna ask if you could help me understand bit math. I took a class in it. It's tough, man. It's just ones and zeros, but then you need to have some cardinal knowledge of how it's stored within the system, and that's what helps you deal with it. But yeah, a byte is 2 nibbles. We need a nibble. We need the least or the most significant nibble. Change the decimal, blah, 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 blah. Bit shifting and masking. What the hell? So we're just trying to shift the bits over, but there's different behaviors when you go right and left, and I need to just make sure that I'm doing the right thing, because I can just simply move it over for one. For the other one, I can mask it, and then that'll allow me to get the right stuff back, right? So I need to do like a bitwise and then and it with a 0 or a 1. I know, it's all bytes and nibbles and bits, just whatever. Just deal with the nomenclature, okay? I want to split it apart so I have a 7 and a 6. This is exactly what I want to do. I want to send the 76. What are you doing? 0 print ASCII digit. I don't want an ASCII digit. Oh my god, everybody just gets crazy when you start asking these questions. I would just like a definitive answer on how to bit shift it over to the right or to the left. This is just our way of passing a simple argument in. I mean, I guess I could pass in the whole character. Hold on, I'm gonna cough. I guess I could just pass in the whole character. We could just put it together that way. And that way I can use easier functions. It just seems a little wasteful because we don't have like 255 timers that we're gonna be setting up, right? But we could do just a uint 16, and then I could do high byte and low byte in order to pull it out. I'll just do it that way, just so we can keep moving. You know, if I need to lighten up my code, I guess I can, but I would like to do it in a little bit more of a flexible manner, but oh well. Oh well. Where's that Arduino reference page that I had open? Oh, here it is, high byte and low byte. Yeah, we'll just do high byte and low byte. That'll just enable us to do this easier. So we'll store the timer ID and the repeat command. And so instead of timer res 4 is going to be the high byte of timer number. And then if the low byte of timer number is equal to 1, return a 0. That's it. So now we just, whatever we get in the packet, we can stuff into that timer. So we just do the time conversion, and we throw it in as its own unique ID. That's kind of what they did with the packets on this stuff anyway. They just kind of threw it in as its own unique ID. And then they just like, they had 2 ID numbers, which is weird, but it's just the way that they categorized everything. So anyway, return 0, return 1, and that just repeats the timer. So repeat is true. That means we return a true, but that also means that the timer number needs to be 0. So if it's equal to 0, then we return that it's not a repeat timer. So we've updated the send packet now. We've updated this. So we actually do need to send that the timer's expired. So before we do our returns, we got to sned. How do we do this again? We are snedding our thing. My send command is beyond reasoning. You'll never understand it. So we sned this entire thing. Timer response. Where did we go? What is happening? Oh, okay, yeah, we're here. We're here, and we send timer's expired. and then other stuff is going to happen. But once we send timers expired, we then set up our own internal timers on whether or not they repeat. Gabish? Gabish. Because once this finishes, the base station requests an RSSI. So if we can implement this function to run whenever a timer expires, we're good to go. We're Gucci, right? We're not going to be sending, we're not having any interrupts here because we timer tick, and timer tick runs our function. Yeah. Get that gabagool. Gabagool. It's gabagool, but I always heard it as gabagoo. It's like gabber goo. It's what like real hardcore ravers drool. Okay, it's actually a meat. Gabagool type of meat. It's more the Italian kind of thing, which I've been adjacent to, but not privy to, as somebody who grew up in this area. All right. So far, so good. I'm actually pretty competent. I don't know how competent I am. Listen, that's between me and my competence. No, I am pretty confident in this now. So instead of just storing like a simple timer thing, we're storing like a 2 bytes in order to define our timer. Now, we need to figure out what our timers are actually going to be. Now, we could do an array, and we could store our timers in an array. Exactly, we're going to do that. When we get a timer in, I guess we define the function, and then that just sticks, right? And so the stuff that we programmed for this thing to do, shouldn't that just be in the code? So we don't need, how do they do it in the example? Where's my example? We're trying to use a library to do all the timing functions that we wanted to do before. We were going to do it with arrays. We found a library that seems to be able to do everything pretty nicely, so we're going to see how we set it up. So when they call it, they just say timer this, toggle the LED, and toggle LED is this function, and they just have like text in the function. Okay. So if we set it up with a variable in there, toggle LED, and then the ID number and repeat stored, we can just pop it in there. And then it'll restart itself if possible. And then when we get a 0 timer, we need to set it to stop whatever timer. So let's take a look at that. So now we're into the regular code. We're timer.every is going to be set for all of them, even though we'll just have one function. This will be pretty elegant, actually. So we do our setup. We're not doing anything in setup. We don't care about the timers in setup, unlike the example code. But now we're going to timer tick, and then we push this into get packet. Get packet will just look to see whether or not the packet buffer has anything in it. If it doesn't, it comes back, and we're going to timer tick again. So we're mostly going to be tick, 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 right? We're going to be doing this again and again and again. I'll have to put some serial prints into the timer stuff in a minute. Let's get the structure of the code down, and then we'll put the serial prints in, and then we'll be able to run it and see where we get to. We'll probably have a lot of errors. So if we do happen to get a packet, oh God, what is this? It's all crazy. Everything is fucked up. No, actually it's fine. So the CL and ID from the packet are being thrown into this variable. uint 16t CLID is equal to this and this, and it is starting with no value in it. Well, it is starting at whatever is in there, so we need to make sure that whatever we do, we clear the packet afterwards, so that there's no CL and ID, and it's just making a 0, 0. So actually, our first case is, I'll put that a little higher up. My very first case, I knew this city had something for me. Case 0x0000. If it's nothing, break. And there's that. That just means we're hold on a sec. That just means we're moving ahead. Man, I've been okay with the cough. The cough is getting a lot better, but got a lot of good sleep last night too. Didn't get to bed early, but I got a lot of good sleep. It was raining. It was so windy that rain was just like pelting the window by my face. Okay. So this is all if we get a packet. If we get a packet, all of this stuff does. And if we don't know the packet, then we're going to print it out. If default, if it is that, I think if we get a timer, that's where we are here. This is the case that we're looking at, is set the soft timer. So send success, send this, and then the success after. What am I setting up here? Let's get our SSI. It'll send this back immediately. But if... Okay, here's the deal. Hey, JK, how's it going? So when we get a packet, when the timer expires, we send that over. And then we get... Damn it, give me a sec. When our timer expires, we send it to the base station, and the base station responds, I would like to listen to an RSSI. I would like to see the baby. Here's where it's setting a different timer. More stuff there. But then we send 2 packets when we're done, right? We send a, I've received your request for RSSI, and I will now send you what the RSSI is. So that's not this. So we don't need, we're going to retool this a little bit. This is where we store the timer. Okay. Okay, I think I got this straight. So what happens is when we get the RSSI request, we say, hey, we got it, and then we send like another packet that represents the RSSI. We're just faking it. That's just like a recorded packet that we send back to it. So we're like, oh yeah, our RSSI? Oh, it's still that same value. Isn't that weird? We just send it back, and then we clear everything. Okay, so now I know where we are. So we've received a hardware set soft timer, right? So we get this packet, and now the only thing in our byte array is the ID. So here is where I set up my timer. Here's where I set up my timer, and I'm going to say char blah, 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 is equal to it's a character array, so it's 8. So that's going to be ID and then repeat. Wait, so there's 2 pieces of data that we need. 2 pieces of data. What are we doing? Where's my data sheet? There it is. Single shot and handle. Handle and single shot, all right? So handle and single shot are 8 and 9. So this would be where is my input buffer of 8, and then input buffer of 9. What are we doing? We are shifting it left 4 and XORing it together. If we're going to follow that, then we're just going to do what we did with the other one, which is still in my notes. Where are my notes? Bring me my notes. There we go. So that would be equal to 32. Oh yeah, we got to cast it as the right thing. Okay. Oh god, this is getting complicated. Uint 32t of the input buffer of 8 is just the beginning of that, and then we take, this is a little weirder. I could probably do this in one step. And then ba, 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 ba. I need a better variable name for this one. Blah. Blah is easier to type. Blah is equal to is bitwise XOR, no, bitwise ORed with ab input buffer of 9. Whew, I think we did that, right? I think that works. So we're basically, oh yeah, we need to shift it. Input buffer of 8. Wait, if we go 9 and then 8 is shifted over by 8. Right? Oh, and I need to cast it as a uint32 underscore t. What we're doing is we're casting it as having more bits, and then we're shifting it over to that location, and then we XOR it together, or sorry, we OR it together so that the zeros don't do anything. What's the OR again? OR gate. Why that takes so long? I don't want electrical tutorials. What the hell? God, you got to fight everything for information these days. The locations with a 0 will give you a 0 or a 1. That's the point of the XOR with the zeros. Whereas the locations with the 1s will give you a 1 regardless. But that's what the OR is all about. XOR just makes everything topsy-turvy. XOR means you get the opposite depending. Oh god, it's ridiculous. Anyway, so we're ORing it together with the zeros that we've created by creating a blank input buffer with the 9th byte sitting in the least significant location, and then the most significant location we are taking the 8th byte, shifting it over, punching it in. So up here, just to recap, high byte is the ID number that we're putting back into the response. The low byte is whether or not it's a repeating timer and whether or not we need to end it. Ooh, okay. So there's that. All right, so what we've got is a character array that we've created and we've put data into. Then we need to set up the timer. And so in order to do that, it's timer.every. We need to set up the time for the timer. So it's going to be something or other, comma, and then we put in bleh, and that's it. Timer every bleh, and then depending on the value of bleh, that'll start up a new timer. And we need to see whether or not how we can cancel timers too. I guess if we set a timer to 0, it's immediately going to expire, and then the repeat character when you set a timer to 0 is do not repeat, and then it won't repeat it. So it'll still confirm that the timer's expired according to our code. Interesting. I wonder how that's going to affect the system. I guess we'll get there when we get there, and we'll see whether or not we need to retool our software. So what we need to do now is we need to figure out what that interval is, and the interval is stored in milliseconds according to this timer, which we're fine with because we don't really care about the timers being incredibly accurate. And if we want to, we can change the conversion factor in order to shorten the timers too. So what we need to do is we need to make a giant, a 4-byte binary number, and then we need to multiply it by the conversion factor that'll give us the number of milliseconds between timer expiries, which I think requires us to divide it because ticks are very fast. So in our code, what we had last time was this. We had this big store timer thing. Time stored is equal to a bunch of stuff. So we need a uint 32, 8, 8, 16, 16, 16, 32. Why am I making those into 32? I need uint 16s on that. Uint 16 is a thing, right? It is, okay. Yeah, because then high byte and low byte gets the right thing. So yeah, okay. So now we need to like make our timer. Ugh, okay. So this is store timer ID and repeat. Then this should probably be a function, to be honest. If I really want to clean up this code, I would make this a function, because I don't like to have all this mess in my switch cases, but we're just going to do this right now. I just want to get this done. So what we're doing is we are storing the timer in milliseconds, and we're doing this. So this would be a uint32t time stored, and then we don't XOR the first one. We just shift it over 24. No, we don't XOR the first one, but we need to reverse this whole sequence. It needs to be, because it's little endian, so 3, 2, 1, 0, and then 24 shift for this one, because the first thing to come in is the most significant. Nope, that's wrong, that's wrong, that's wrong. Hold on. So we're creating it, and when we create it, we should probably have the first thing that comes in should be the least significant, because we're flipping it. Oh, God. All right, so this one is 0, 1, 2, 3. The last thing that comes in, what direction is that in again? That's most significant to least significant. Yeah, so this one is shifted 24. This one is shifted 6. I don't need to cut and paste that. This one is 8, and this one is 16. Is that correct for the order, the byte sequence? So serial buffer of 0 is just stored as the time stored, and we don't even XOR it. That just comes in, and that gets the 0th thing that comes in is the soonest thing that comes in, and the soonest thing that comes in little endian, or whatever you call it, that would be the last number, which would make it the least significant. Yes, so that's correct. So least significant, middle, bigger, biggest significant. So that's putting it in the right order for us to do math on it, you see. All right, so how do we convert ticks into milliseconds? So let's look at the data sheet. Frequency interval of events, which indicates how often to send events in hardware clock ticks. 1 second is equivalent to 32,768 ticks. Jesus. Okay, hold on a second. All right, I don't think we need the blink example anymore. I think we've got I think we've handled the library so far. We just have to see what happens when we run it. And so right now we're just setting up to run it properly. So we need ticks. So timer in milliseconds, 1 tick is equal to 3768. No, it's 32,768. Why do I keep opening this? You get out of here. You distracting ass window. I hope this is fun for you guys. I hope you're happy to hang out. You know, it's going to get a little cooler once we start running this code. And I think this library just like rocketed us ahead. So is it a power of 2? So that means that I can just bit shift in order to do the math. Yeah, good eye, JKIV. So any parameter between 0 and 328 will be rounded. (10 milliseconds, 328. 32768. Oh, I got the right number. 10 ms is equal to 328. 328, oh, 328. I think I used to know somebody with that number, and that's how I remembered it. I think that was a mnemonic back when we had to write down numbers and stuff. 2 to the 15th. But I need to divide the number that I have stored in time stored into whatever I need here. I need to like, I need to organize this. Hold on. Oop, there we go. So what we're doing is we are shifting the numbers in as ticks. So currently it is stored in ticks. So we need to take time stored and we need to turn it from ticks into milliseconds. So we would divide by 328, but it is a multiple of 2. So would we shift it 15? If we shift it, because divide by 2 every time you shift, right? If we get, well, 328 divided by, I don't think that's going to work. Hold on. How do I do that? Between 0 and 328 will be rounded up. If I do a divide, then it gets hinky, doesn't it? It's in hexadecimal right now, right? What's in hexadecimal? Stored as a long, basically. It's an unsigned long. So I need to take that unsigned long and I need to divide it by 328. I don't think we shift it. I don't think we, no, that's not right. That's not right. Bitmath is complicated and I don't know anything about it. No, I do. I took classes in this. I should know how to do this. But generally, like, I'm trying to think of like what the function would be in order to bitwise divide it. I don't know if there's a simpler way. I think we just do a divide. I think we just divide it. I think I just divide it by 328. 1 second is equal to 32768. Smallest interval, 10 milliseconds. Any parameter between 0 and 328 will be rounded up. If I divide it by 328 and then put a 0 on the end and multiply by 10, does that work? Let the compiler sort out the optimization. Yeah, I guess that is our option, huh? It wouldn't be divided. 328 is not the conversion factor, though. Because that's what you get to get 10 milliseconds. Although they say it's rounded up. So does that math work out? If we've got 1 second, and that is 32768 divided by 328, I get 100. Yeah, so it's divided by 32.8. Which is almost equal to 1 second, rather, 1,000. At 327.8, huh? If you wanted 10 milliseconds, you'd say anything below 328. Anything below that. If it's a division by constant, the compiler has the option to convert it to a multiply by constant using fixed point tricks. Yeah, so I guess we're going to lean on the magic of the compiler to do the work for us. The microcontroller nerds out there will be like, but you're supposed to use point dot bitmath in order to, you know, put a multiply by a near physics number, and then you use like a reference, and then your reference has like a return that'll then flip over this bit mask in order to, you know, like they'll do weird binary tricks in order to do this. But I think we'll just rely on the compiler. So 32.8. And then that's conv factor. And we can, by the way, we could change the conversion factor. I could make it 3, or I could make it 328, and then our timing all gets smaller, right? And if I do that, it might be that the Granite devices controller doesn't care, that we can just make everything happen faster. Because it might not, I don't know. It is setting these timers, so it's probably relying on the timers to a certain degree. But I mean, I don't know. Maybe we could make it faster. We're not going to get that far into it. 32.8, so that's what we divide this number by. In an affront to all microcontroller programmers everywhere, we're going to divide by something. So then time stored goes here. And so according to how this thing happens, or according to how this library works, and I'm not an expert on this, I could be wrong, but from what we know, that ID, bleh, that I've put into there, that is just simply going to, and that'll have two functions to it, but that argument gets passed in whenever that timer expires, and it runs the timer function, I think. Or are we, wait, do we have to define the function? Hold on, wait a minute. Wait a minute. I think I need another argument. I think I need to call it a thing. Oh no, I've closed the example. I thought I was an expert. Don't worry, everything will be fine. Nobody panic. Let's see, where are we? I keep looking at the wrong monitor. It doesn't look good when I'm like looking down at the other monitor to find what I'm referencing. Arduino timer. And then, I don't know, blink micros. Micros! Oh, see, we need to do that. So we need to do... We're not doing default, I guess. Where did I set up? I set it up down here. Timer, and then we're going to give it 5, even though we don't really have to. 5 tasks. Arduino timer. The include should not be all the way up here. I guess I'll sometimes do that. I'm not really consistent with that. Include timer. Timer 1, micros. So we're setting that up as timer 5 instances of microsecond timers. And then we've got our function, which has a Boolean return. And then I'm passing in a uint16t. All right, Blue. Thanks for stopping in. And then it's just timer every amount of time. What the hell is this? That's not the number of micros in 1 second. Wait, a million? That is the wrong... What the fuck? What is this? Every micros, you've got it's 1,000 microseconds for 1 second. What's going on here, timer library? Hold on a damn minute. I hate finding stuff like this because you just don't know now. You just don't know. Micros in... Oh, handler argument of type int. So that needs to be, it needs to be micros and then uint 16t. T. There we go. What's up, Lexo? 1 micro is 1 millionth. Oh, a milli. Yeah, you're right. Thank you. Yes. Okay, I'm dumb. I'm dumb. Yeah, so we don't need that argument in there. But what happens when... I guess I just don't include it. So we just don't include this. Okay, yeah, I'm dumb. So timer 5 instance. I'm editing the example. Hold on, I'm in the wrong thing. Oop. So what we need is 5. We don't need micros. And then we need uint16t, because that's going to be our argument that we send in. Hey, Proteus. Yeah. I got it all wrong. I'm dumb. So that's the timer that we're setting up, and we're calling it timer. Auto timer, I don't know if we need. Yeah, we don't need the auto one. Just different ways of calling it, I guess. But it says int right there. You don't put a type there, but they have it there. We need an example. Nope. We need a different example. Examples. Arduino-timer, blink print, full? What's full? Ugh, and they got a reference. These are different timers that they're running, and they're defining different ones. Create a custom handler type of constant character star. So I guess, do I need the star in there? I didn't have that in the other one. Print message, constant character star M. Oh my god, I wish I knew how this stuff worked. Example, new example. Let's just look up another one. I don't know about this Unix host crap that this guy is actually calling in here. What is this? This is a little bit more. What the hell is that? Simillis. Do I need to put millis in there in order for it to work? I don't know. This is, what the hell? Like, file, examples, timer. Please tell me what I need to hear. Yeah, this one sets up a default timer task. Timer number, micros type. So if I do give it a type and I want millis, do I just do millis like that? Because he doesn't show millis using a handler argument. That's why I'm getting confused. So I do need to provide it. See, I thought it was one of those deals where they would like give a default value or something like that. I guess it's not like that. So delay function to call argument. Okay, interval function to call argument. Got that. Auto task timer in. To cancel a task. Okay, so we'll need that. Check if a timer is empty. If timer's empty, no active tasks. Number of active tasks. I wonder how I guess we just don't worry about that. We just don't really worry about that. Let's give it like 2 tasks maybe. And if the tasks fill up, we can print out whatever the request for the packet is. I don't know. Let's okay. So supposedly we've set it up properly now. So we have the arduino-timer.h initialize or included with this thing. We have the timer set up here. We've set up 5 concurrent timers are possible within the millisecond timer. We set up a millisecond timer, and then we set it up to take in a uint16t. So the first 8 are going to be our ID, and our second 8 are going to be a 1 or a 0, determining whether or not it repeats. And if it doesn't repeat, then we return a 0 from the function that it calls. So when we set up the timer and we calculate all that stuff out, we have the timer expireds function run, and that'll get the uint16t passed into it of the ID and the repeat. So the ID and the repeat comes in as timer number. So we take the timer response and we use the high byte. So the high byte's the ID, so that's going to punch the ID into our timer response packet, which is the last piece of the timer response packet right here. So that's the ID, and then everything else in there just tells the base station that the timer that it assigned to this ID has expired. So that gets sent. If the low byte of the timer is equal to 1, according to our data sheet, if it is a 1, then the timer only runs once. So we return false. If it is a 0, we keep it going. We keep it going, baby. So that's how we do that. And then when we push the timing into the thing, we need to have it cancel the timer of the ID. We don't know the repeat status necessarily. How do we make it do that? Uh-oh. Well, we don't know the repeat status of the timer, so it's hard for us to find that ID again. We need to know which timer we need to cancel. If the timers are defined in this thing by their timing, how do we know which one to cancel? This is like a shower thought. If our eyes are real, how can we be real? Oh, I could actually use this function in the complicated thing below. So yeah, if we get a timer packet in, this one can just be what does the other one look like? The other one did the shift first, but it's CL and then ID. CL is shifted 8 and then the ID. We just kind of like reverse them. But if I do this, I can just do input buffer shifted 8 and then do that just as it is. So that we're just creating our whole thing right there. We'll leave a comment right here. No, wait, that's timer ID. That's different. That'd be like something here. Uh, 3, 4. I don't know. I'm just representing it all. That would be like cancel a timer. I don't know how I do that. Yeah, no, I think Wexa's Pyro's got it. We're trying to look like a wireless module so that we can set buttons off on the base station. And so what we need to do is we need to set up 5 concurrent timers that the module is able to do. Now, I've faked it in the past, but I need it to be a little bit more malleable code because we need to get through the boot sequence. And the boot sequence is doing a bunch of different stuff. So it's coming in and it says, hey, set the setting, set this setting, set this setting, set a timer. And then it waits. It's a little game that it plays. It waits, and then the base station, or sorry, the module goes, hey, the timer expired. And then the base station goes, oh, set this setting, set this setting, set this setting. And then it goes, hey, here's another timer. Ooh, unset this timer. And so I need to actually implement that within our code. So I don't know how to unset a timer. If it sets a timer and then it sets it to 0, it's not going to necessarily unset the other timer. We need to somehow find the timer. How do we do that? How do you unset a specific timer? And how do I find that timer after the fact based on the ID code, which would be the argument that we pass into it and the repeat, whether or not it's repeating. So that, oh, God damn it. That might not be right. That might not be possible to do. cancel all the timers, but there is an instance where this thing comes in and it says, hey, timer 2 is now nothing. Now, timer 2 is set to repeat, so 0200 is always going to be the argument. But what it wants to do is unset timer 2, and we don't know where timer 2 was set to. And then we, of course, verify that we got that command. This is where our capture runs out, by the way. There's another timer that gets set. It's a 1/3 of a second timer. We don't know what's going on there, or if there's more handshake that occurs after this. So this is where we are, and I'm trying to get us there. And if I can have configurable and resettable timers that are stored by ID, then we can get there. It's just right now, they're not necessarily stored by ID. I can look at the number of timers that are set, but I mean, I guess maybe if I keep track of which one is which ID, I could keep an array of 5 bytes and keep the IDs in there. And then that'll give me the 1st, 2nd, 3rd, 4th, and 5th timer. But how do I unset a timer? All the repeat X time functions with millis. Call the print message function in 5 seconds. How do I cancel stuff? Yeah, T timer tick, U timer tick. I see, that's where they ID it. I mean, on the GitHub page, they talk about it. I just wanted to see an example. Timer, ooh. Clock set, clock millis, delay, clock delay, reset, clock reset, duration runs, task, oh my god. Huh. I have no idea what this code is doing. It's crazy. There's a cancel method. I think the function you call for the timer event you want, you return a false to stop it from going again. Yeah, that stops it from repeating, yes. But what happens, so what we're trying to do, yeah, I'll look at that in just a second, Sissy. So what we're trying to do is we're trying to be this module right here. So this module right here has a system. Oh god, I'm beeping. Hold on, I'm just beeping. I gotta, every time I beep, oh god! Yeah, so the crappy pizza had some carbohydrates in it, didn't it? Let's give another 30 grams of carbs for that. Also, sitting around doesn't help. Okay, so back to what I was talking about. We are trying to be this module. The Granite device's base station sets up a bunch of parameters in this module, including a couple timers, right? So this module is capable of running 5 concurrent timers. They are given an ID number. And so the packets that are coming from the Granite device's controller reference a command, a value, and an ID number. In this thing, in this timer thing that we're setting up, we have the ability to set timers. How do we unset timers? Because we're not identifying them by ID. And that would be all well and good if we could set different IDs. But we have, from what we've seen so far, we've seen timer 2 might be the only timer that it plays with. And it tries to cancel the timer. So in that sense, I mean, maybe I could just leave one open timer and I could just have it so that if it gets zeros, we just cancel all the timers, right? We need to look at that cancel method to figure out how we ID the timer that we want to cancel. Because otherwise, I'm going to have to store like the timer ID and then whatever the library uses to ID the timer. We're going to have like a translation matrix that we reference in order to figure out what the fuck we're supposed to do. Because from what I see from the library, it does it by time, which is not how our serial signal coming in does it. Does that make sense? Did I explain that right? I hope it does. With these programming streams, we have people of all kinds of different skill sets, and attention spans and watch times, all flying in on the project. And I like to keep people up to speed, but to a certain degree, I have to get snippy so that I can actually continue to program. In this case, you guys are my rubber ducky. It's actually helping up quite a bit. It's helping a bit. I should be scheduling a haircut because I look like a goddamn hippie, but whatever. I can't believe you guys would judge me like that. Be fancy with lambdas. I don't even know what's going on here. We can look at the number of ticks. Whew. Ooh, that was a pizza burp. That one hurt. Yeah, so cancel. That's active tasks. Cancel all tasks. Timer.cancel task. Auto task is equal to timer in, and it's an auto. Okay, how do we what? How do we task? What the hell is auto anyway? Automatic storage class, this variable that has a local lifetime starting with, that's Visual Studio though. This type is deduced from the initialization expression and its declaration. Yikes. Yeah, so the compiler figures that one out. That's like, you do it. I don't care, you do it. Yeah. Man, if this is like, that's like the bane of C++ education, wouldn't it be? Like all that stuff they tell you about being careful about the types of variables that you run. You imagine if you knew about auto and you just used auto for every single one. Like, I let the compiler do it. The professor's head would explode. It would fucking explode. It would be like scanners. All right, so auto is encouraged. I mean, I'm going by the psychological profile of the people that taught me how to code, and I would not think that they would be so keen on it. So that comes to me as a surprise. So, all right, I'm trying to understand this. Task is equal to timer.in. So every time we get a timer, we can assign it to a variable. How do we fucking... Wait a minute. We need to check the number of tasks. And then we need to assign the task to the timer. And if a timer is canceled, we need to go to that task. So we need an array of ID numbers. And then when that ID number is requested to be canceled, we can cancel that specific task. If that task ends on its own, we also need to wipe, I guess, that task for that ID number, or we just don't care. Or we just don't care, because if it no longer repeats, it doesn't matter. And the repeat is already in the ID number that we use. The ID is not used as a task. But if it's set suddenly not to repeat, then that changes everything. Son of a bitch. This is getting very complicated very quick. Unfortunately, and let me re-explain what's going on here. Right before I run out of data on the oscilloscope in order to decode what the handshake is, they go and they run this bullshit where they cancel a timer. So they go ahead and they cancel timer 2. Timer 2 expires, and then they go, hey, unset that timer for me, by the way, bud. And so we got to be like, boy. All right. And so I guess we have to reference it by task. I guess if we do that, that's okay then, right? Well, you could pre-make them, but I don't want to do that because we don't know how it's going to be handling the timers in the future, right? We don't know what happens after this 2.5 seconds. Yeah, I mean, if we know that there's going to be 5 tasks, only 5 tasks, then we could make an array of 5, which is, I guess, what we need to do. And then whatever location in the array is the number of the task. But we should probably store it directly through the, because I don't know what it's going to assign this as, right? I don't know what that's going to look like. So we'll just store that in the second row. Or we store that in the array based on the ID number, because there's only 5. So 0 through 4 can be our ID number. And if we look it up by the ID number, then we can translate that over. It'll be just the plus or minus 1. So this would be, well, we don't know what to assign. I don't know what type to assign task to, and neither does the compiler yet. I don't think I can just do an auto array. Auto array, roll out. I don't know what it's storing the tasks as. Is that valid? I don't, oh, that sounds like cancer. All right, fine. I'll do it, but I won't like it. Oh yeah, it's 4 actually. Actually, 0, valid timer. I don't know if it's ever going to ask for timer 5, so we could just take that number directly. Right? So that means when we get this and we translate it into milliseconds and we put it in, that means that whatever number ID we get goes to that location in the array. Is it a tradition for documentation to always be this way? I still have flashbacks from trying to learn ISP32 from scratch. Sorry, ESP32. I don't know, man. I don't know. Documentation is always just like the worst, right? And that's auto type. Oops, no, that's not right. Time stored is equal to the time stored over the conversion factor. We're doing division, straight up division, just to trigger all the programmers. But when we make the timer, we store it with our character array that tells us whether or not to repeat, and then also we give it a task. So the question is, if we get, I mean, if this cancels, then we need to go ahead and we don't need to wait. If we cancel the repetition of the task, it will reassign that task number later. We don't care if it still sits in our array. So I think this is good. Why is there a dead kidney in my chat? Sorry. I love Twitch names. We don't get to concentrate on them as much now that the board is down for the count. The board will be back. We'll work on that very soon. I want to knock these things out. We got a big rainy day going on today. We're going to jump into the computer project on probably Tuesday. Well, I'm going to spend Sunday and Monday printing all of the panels for the PC. And we can probably put that together on Tuesday. And then, assuming that this project is done, because we're going to work on this thing today until I fucking die, we have, I guess, the field open to begin. No, not Torbian Tuesday. I also got a mini dosimeter that I would love to take apart with you guys. But maybe that's a Friday project. Next week is a little hinky. I don't know what's going to go on in terms of stream schedule. That's my stream is it just starts and I go, it's a stream schedule. Next week is kind of hinky in terms of my stream schedule, but then the week after that I can stream a lot, and so we'll do like gaming streams and stuff like that. just because I'll be here alone, which means the sky's the limit, right? I can only tell people to be quiet during certain hours of the day around here, so it gets kind of rough for me to do like excess streams and stuff, but I want to. So we have enough project to fill the day. We'll do more burn the subs, and so we need to do the melting of the PETG prints. We need to figure out how to seal stuff properly. I need to cough. We need to put together the system with Clipper, which is going to be even weirder in terms of the programming, and get in there with the API. And then we need to alter my code in order to make it work. Hook that all back up, get it water cooled. That'll be cool stuff. There'll be like little mechanical designs for like drag chains that hold tubes, things like that. That was a pizza burp. That was fun. That was a lot of fun. That was fun. Fun. Let me get more soda, because that's actually what's tamping down the pure grease that my stomach contains right now. I was like, I'll get a treat. I'm gonna get a pizza. That'll be great. Yeah, I've been okay about diet this week. I'm gonna have a treat. I'm gonna get a pizza. It's the worst pizza I've ever fucking had. It's so bad. Oh my god. Yeah, every project is a one-day project, even this one. Every project, one stream, single stream project. Suds, go away, Suds. Go away, Suds, I have a stream to do. All right, so I'm a little bit more confident in this. If we get a 0, so if time stored is equal to 0, we need to cancel that timer. And so the task is referenced as a location in the array. So time stored is equal to 0. We still have the global variable of the ID, and the ID is where it sits in the task array. Because we've only got 5 timers, there's only 5 IDs available. So we can go timer, cancel, and then task of ID to call it back out. It's easy peasy lemon squeezy, right? Let's double check that. Yeah, task of ID. Huh, that was easy. Timer.empty, huh? Number of active tasks. These are weird functions, you know? Ticks until the next task. It's so weird. So because we're calling this every loop, this should be isolated. I don't think it's interrupting. So that means that we can just run it as part of the normal tasks that we do with this controller. I think maybe this software, the one that I'm writing right now, is where, I mean, obviously when we're done with the boot sequence and everything, I think I can pull code from the LinBus manager over to this. It's going to be a big program when we're done, but the LinBus stuff happens in sequence with this. So we will have a section where this pull, and maybe I need to move the state machine over to its own function, and then we'll have the 2 functions that go. So one of them will be, you know, call for all the data, put the data into packets, check if there are, or well, call for the data, look for changes, send the changes, and then the timing tasks. And the timing tasks will then keep us connected and everything. And that way we'll be able to get everything from the LinBus, put it all into the packets if needed, send them out, etc. We'll probably have to do an analog write every loop on the potentiometers, which is fine. Maybe multiples. I mean, maybe we read the LinBus a couple times before that timing task comes up. Oh my god, it hurts my brain. This is a big piece of software. I don't know how y'all do this. Okay, I think that's everything we need, assuming it works. Assuming it works, I think we have everything we need. So we have a system by which this thing can cancel a timer if it's requested to cancel a timer. We have a system by which it can do repetitious tasks or non-repetitious tasks within the function that gets called. We have a function that gets set and called on its own. We have up to 5 timers. So those are all the requirements. And we store the timer based on the ID that's requested by the base station. So if the base station double requests a timer, I don't know what to do. It'll just have to figure itself out. And I don't think it does. So I think we're suddenly ready to test this, which is a little bit scary. Let's save this. I'm going to use the bathroom. I'm going to take a break. I'm going to take some steps. Chat, move your legs. Move your legs, chat. I don't want you guys getting blood clots. I don't need you guys any dumber than you are right now. If a blood clot starts in your leg and lodges in your brain, you're not going to be able to do code review for me, and my overall IDE gets dumber. Especially for the person that just opened my stream, I saw the average IQ lower a little bit. Whoever just came in, so I'm not happy. We don't need it to lower any further. So you guys go move your legs a little bit if you can. Move your bodies, I should say, if you can. I don't think there are a lot of brains in jars watching, but you never know. It's never zero, technically. But anyway, I'm going to go stretch my legs. I'm going to use the bathroom. I'm not going to eat a piece of pizza because that would be torture. What emote is that, JK? I love it. Jesse, please. Oh my God, that's perfect. Sorry, every now and then one gets me. And the meow with the legs is always good. If unexpected behavior, then freak out. We have if unexpected behavior, then print out. We need to add a couple prints into this too, but I'll be back in just a second. So I'm going to put a BRB up. I'm going to put up a BRB. And I'll put a little music on so you guys know things are moving. We'll put it up on this screen. And actually, I'm going to hit save. And I'm going to put this in the Discord. So if you guys want to look at it, we're not done. We need to put the serial prints into this thing so we know when timers expire and stuff. But I will put what we have right now into the Discord since we got a little break in it. If you guys are still, oh my God, going ahead printed a gnome. That's hilarious. Sorry, I haven't looked at the Discord since I started streaming. So project stream Mercwheel. And then we've got Arduino, and this one's our button flipper. We haven't made it flip buttons yet. That's what the 2 little switches that are attached to the Arduino can do. We can make it inject packets now and see if it triggers packets within the Granite devices stuff. But yeah, there's the code. It's in the stream project section of the Discord. I'll be back in a second. Woof. Man, my stomach like hates me right now. Hey, Portal, what's up? I was just stretching my legs a little bit there. Okay, stretching my legs and my bladder. I gotta get that Stream Deck XL working. I am starting to run out of buttons. All right, lowering this. Bonk. Okay, hi everyone, hi. It me. We're ready to test the software. It's been through a couple major code rewrites. So, I don't know if it's gonna work. There's probably just an obscene number of missing parentheses, missing semicolons, all that kind of stuff. But I believe that the logic is at least somewhat sound. We have timers that are given task IDs that are able to be set if we get the appropriate packet. That's this case right here. This should probably be functionized. And actually, let's do that. Let's just take this whole thing and do timer store. So we'll do, instead of, wait, why are we clearing? Oh wait, I went too far. So case is the timer set, and then we do set timer. We'll just make that a function, and that's going to kind of clean up. That's going to clean up everything. Since the packet is stored globally, we can just go down here, and where we're sending bytes, send success, clear packet. We can do void send or set timer. Used to have a professor in high school that had, teacher in high school that had an at the end of his name, 2 ers, and I was like, wait a minute, like, how do you say this guy's name? So yeah, that's just set timer. So what happens is we store the timer ID and whether or not it needs to repeat as a character, as a custom character within this function. So we then use that when we set the actual timer, right? We actually use that in order to set the specific task. And that way, when we run the function, we can pull that out and see whether or not it needs to repeat. So in doing that also, we need to actually make sure that the timer is being set to a positive value. So we actually put all of the, all of the bytes in the array we put into a uint32t, a character, right? A character is 2 bytes. I need to open that bits and bytes thing. I need this. I need to like print this and put this on my wall. God, I'm so dumb. Listen guys, I've gotten pretty far on my dumbness, and I don't have any plans on not getting further. Wait a minute. Well, it's word. I guess it's character, but whatever. We got 4 bytes, right, for a character? I hope. Anyway, 32T, unsigned long. A character is 1 byte? Oh. Well, it's possible that I did something wrong there. Wait, I'm casting it as a uint16t. So uint16t. Well, I might as well just keep it as a uint16t. All right, so whatever. uint16t. We're storing it in 2 bytes instead of a byte, right? And that way we have just exactly what is sent to us, whether or not it repeats, and the ID that they're assigning that timer to. There's a possibility of 5, so we just have an array of 5 bytes that we store the task IDs in. The task ID isn't a byte. We don't know what the task ID is. We have an array of 5 that 5 based on the numbers 0 to 4 that we did. So whatever. Timer 0, timer 1, timer 2, timer 3, timer 4. And so we'll just set and unset that as we see fit, as we're commanded to by the base station. I think that holds water. I think that's okay. So what we do is when we get the time in, that is in 8 bits. That's in a long word. No, wait. That's in a very long word. I don't think these terms are correct. Anyway, it's in a long, so it is 4. I don't think it's 8. I think it's 4. I think it's a long word. I think it's just a long. But we get 4 bytes in. 1, 2, 3. Yeah, we get 4 bytes in, and we have to endian it. We have to unendian it because I don't know why they decided to do that. Endianing is just like, I don't understand why it exists. I mean, maybe if you're dealing directly with buffers, it makes sense. But in this context, like, what are you doing? Like, why would you do this? It's just obfuscating the bytes. You have to flip the bytes around without flipping the bits around. So anyway, that's what we do. So we take the furthest location and we shift it to the closest location and we populate the numbers. That's just, we do it from the back to the front. I don't know if we can go from the front to the back. We could, I mean, whatever. Why are you judging me? But we do that, and then we see if it's 0, then we cancel whatever that task ID is. We've already stored all the stuff that we need, and we've got everything we need in order to populate or depopulate that ID. And it might need to be ID -1. I don't know how that works. Maybe we'll give our array another value here, just to make sure that we don't. So whether or not task 0 ever gets involved, it doesn't matter. Now it doesn't matter. We're not at 100% efficiency though. That hurt our efficiency percentage. Then finally we need to convert a tick to a millisecond. And actually if we're canceling a timer, we can return at that point. So if we're canceling a timer, we return because we don't set it as 0. That'll cause problems otherwise. We'll put in a serial print on these. Well, actually, let's hold on. We return, and then the tick to milliseconds. So if we didn't hit this, then the tick to milliseconds goes, we take our time stored is equal to the time stored over our conversion factor in order to turn it into milliseconds, and then we assign the task ID into the array based on the ID that comes in, based on the byte that comes in there. So the location in the array is set by the 0 to 5, and then it's going to equal the task that is assigned to timer that runs every time stored with, so it'll run the function that we've assigned to it. Where do we assign the function? Wait a minute. That's the timer. That's the thing that we pass into the function. Double check with the library. Double check. Function to call. Whoopsie daisy. We didn't give it the function to call. Function to call is time exp. So when it expires, we run time exp. And we give it blah. Finally got the code where I liked it for the PCB project. Sorry, LED strip project. Made a small test PCD on perp board. Hey, that's a good project. We need to do a Tasmoda project for the lighting behind my desk, and to fix the lights over there, and to fix the entire milling machine over there. Ugh, God, that milling machine really needs, like, that slide is bad, and so I need to figure out how to test it and how to fix it. I don't know. I'm hoping it's just like a broken wire. Who knows? And I've got to somehow extract it from the machine too. That's going to be a pain in my butt. It's really annoying though, because without that X, I'm kind of shit out of luck in terms of machining stuff. I have a whole new case for the Logitech Brio over here, and I haven't been able to do anything with it. MQTT and Home Assistant for states availability thing uses a topic. If you send the online message that it stays available on the dashboard, they send an offline message. I don't know what any of that fucking means. I use Node-RED, and that does similar stuff. I just don't know what any of that. You've said it. Like, the terminology overlaps like real world functions, which is not good. It's like the availability thing uses a topic. So you have a topic of availability. It like my brain wants to translate it, and I can't reconcile that into anything. But yet at the same time, I do know some of the node terminology, and it's similar to that. But it just, oh my God, you've just like record scratched my brain. Like the dashboard is something different. It's just word salad, right? It's like an AI that's trying to write a movie script. All the coughing has made my like chest muscles start to cramp. I haven't even been coughing that much. All right, so I think we're ready to go with this. It's just I need some serial prints to go in. I need some serial prints to go in here. So serial.println timer stopped. Actually print ID is and then this would be ID percent 20 percent 20x, and that's a printf ID. Do we even have ID at this point? Oh, packet ID, yeah. I need to change ID to packet ID. Task, and then this would be packet ID. Time stored is still good. 32 blah. Packet ID is just going to be a number. So we get a timing command. It goes to set packet. Everything is still in the buffers. We use the locations of the buffers in order to give us whether or not we have a repeating. Well, we have an ID and we have a repeat, and the ID and the repeat are going to determine what we send back to the base station when it expires. However, if we have a timer that we need to cancel, we reference that task ID in our array and cancel it. And we still have the stuff in the holdings. No, well, okay, here's the deal. The timing library that we're using. The library that we're using is on GitHub. It's contrem arduino-timer, and this lets you set up to 10 timing instances with 3 different timing granularities, right? 3 different timers that run at different granularities. So we're using the millisecond timer, and we're setting it up with 10 instances. Well, 5. We should set it up with 5 because we only have 5. We don't need to set it up with 10. The teensy can take it, but whatever. Whatever. I'm going to be nice. I'm going to set it up with less instances. Oh, I already did. So we're setting it up with 5 instances. So it has 5 tasks that it can run. So this thing references stuff as a task, right? It gives it a task. I don't think they're hardware timers. I think they're software timers. But it references it as a task, and so we store an array of those task IDs. And it's only 5. We don't know what it's storing. So it stores 5 of whatever the hell it needs to store. And then when we go to cancel a timer, we're given an ID, because the BM111, the wireless module, allows up to 5 timers, and you give it an ID number. So we reference it by ID number, and we do that by location in the array. If they decide to call a timer like 2F, we're fucked. But I don't think they do. I think they just I think they actually reference 0 to 5. So I think we're in good shape. I just need to make sure we know what's going on, because at a certain point, according to my notes, at a certain point, we run out of data. And there's a bunch of stuff that happens when we run out of data. So I need to be able to record the packets that are coming in at that point. Now, we're not going to respond to any of those packets. So the packets that are going to come in, we might need to set up a dummy response, possibly. we'll print the packet, and then we can act like we received it properly. Let's do that. Let's see if that actually works. How do we? I think we've got everything we need in order to do that. So if we, time sort of conversion with an auto task ID. Okay, so that's that function that we just made that cleans up our. I like to have only functions in the in the switch case array, because I need to make sure that it's simple enough that you can read through it and understand what's going on. So this would be responses to packets. I mean, generally we could actually just give it a generic response and I wouldn't need all this, but anyway, don't know what the packet is. Print packet, sned, success. Sure, yeah, man. I totally know what you asked me to do. Okay. Save. So what we're doing is we're printing out the packet, and then actually it could turn out that for any packet that doesn't need a complicated response, we could just do this. We could have just done this, because we don't really care what it's saying to us. If we need a more complicated response, I don't know what we're gonna do. But after this, we get to respond in kind to tell it that we have a certain MAC address that's connected. That's what we're gonna do next. Yeah, with MQT, you send a message on a channel. I think that's how my lighting works. And the cool part is that OBS is connected to it too. So if I go to the spring arm, boop, that light turns on. Because when I go to the different scenes in OBS, it's being sent as an entire, MQTT or whatever, just big packet of information. And we scrape off the data we need in order to set off the Tasmota stuff. I gotta get back into the Tasmota because I wanna put lights. I have almost everything ready to go for behind my computer desk, which is the 2 previous boards for burn the subs, and then I want to illuminate them. I've got in-channel like little inserts that'll diffuse the light that I printed in clear, and I've got the LED rope sitting behind me. It's 4300K light. It's not addressable, unfortunately. I can't do that. I can't find a narrow enough addressable LED array. I guess we could eventually do that, but it's too power hungry. Right now, I just want it to be illuminated. And then I want to hook that up to a Tasmota controller so that I've got it on the Stream Deck so that I'm able to pop it on and off for gaming streams. I think that would be a lot of fun. I think that would be a lot of fun. Man, you guys want to get high? All you need to do is cough your lungs out and then you get all lightheaded. Remember when they tried to sell that to us as kids? They were like, if you spin around in a circle, it's like getting high. And you're like, I guess. And then you became an adult and you got high and you're like, this is nothing like what they talked about. I don't know. This protocol is weird. It's whatever the BGM, 111, whatever. All right. So we've already got our print packet for an unknown packet. If we reach the end of boot, we say bootered, which we're never going to do at the moment. We have nothing that you can actually program to do that. We could enter a boot equals 1 into any of these in order to tell us that we've made it to the end, but we've already got pretty verbose instructions coming out of this. Now we will blank all of this away or just not even have serial connected for when we do this IRL, or, when we do this in the end. Hey, thank you for the follows, guys. In the end results of the code, basically, right? Print hardware set soft timer. I guess I can write. When we set the timer, we've got verbose stuff coming out of this, right? Well, only if we stopped him. Timer stopped ID. I guess if we're breaking there, I don't need this. Prints in here, and then down here we can do set soft timer. So we can go down here because this is where it would. I need to move the return. Hold on. I see it now. I see it. read command software set timer, and then we're gonna put a space after that. Or sorry, ID, and then ID is gonna be print line, and then it's, we'll just put the ID on it, not the time, we'll just put the ID. And then print F, and then I need a blank print line on it. Father, you forgot the capital S. How can you possibly code like this? You forgot the capital. Why did you forget the capital? What are you doing? This isn't how you code. Father. Okay, there we go. If stored blah blah blah, then we return early from our function. Otherwise, we're going to print what this stuff is, and we're going to continue on. Okay. The question is if I accidentally referenced the wrong thing, like if I called it ID somewhere. Probably did. Yep, I did. Okay. And then anybody else? There's probably 100 errors with this code at the moment. But we'll try to upload it, and we'll see whether or not we can get through the sequence of events. Oh boy, oh boy, oh boy. Log all the things. Yeah, the only problem, when you run down to a very limited processor that doesn't necessarily have a free serial port for you to print everything on, we're not really doing logs anyway. We're doing, I mean, we got to catch it on the serial monitor. And the question is, hopefully, when we do our runs of nothing happening, while the serial buffer fills up, nothing is going to constantly print. But we'll find out. All these codes, all these errors will become self-evident. We've reread this code several times. I'm feeling a little bit confident, maybe overconfident, but we've been able to get serial communications to work. We have never messed with this timer library before. It's simple enough that I think we've got all the right stuff in place. I don't know. I mean, the only other thing that I guess could go wrong is just variables and types, right? Scopes, maybe we need a little mouthwash. Maybe chat needs a little bit of mouthwash. Hold on. Goddamn fucking cough. So what we're looking for is for this thing to come up and get into the mode where it is simply just pinging and it's just waiting for a connection, right? We know what that looks like on the scope, and the scope should be configured to show us that. And we'll look at the serial readout and see if we get through all of our commands. So I'm gonna have to do a quick cut and paste of what we can get in the serial monitor in order to get out all the stuff that's running around on this. You guys ready? I guess I'm ready. Make sure we're all configured properly. Indeed. Teensy 3.2 serial 96 blah 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 com10. Yep. Okay. Here we go. First try. First try. First try. First try. First try. Damn it! Oh no, I don't have a command on that. I must have cut and pasted. What the hell one is that? Oh, that one is a 0C00, so that's a command lay set timer, right? Must have cut and paste errored that one. Let's go back to the data sheet. So that's 0C00, so that's this one. Command hardware set soft timer. I don't even know if we're using that. See, these 4-byte ones are there so that we can determine what exactly is being said. We can compare against this. But we're not really comparing against this anymore. We actually use these codes and we just set them up down here. So I don't know if I can punch something into the case that would make that reference that part of the code, but oh well. All right, I gotta cough again. Hold on. All this talking is kind of bad for me. Upload. Son of a shit. Son of a bitch. Unsigned character 5, because it's probably 0, 1, 2, 3, 4, 5. Wait a minute. That's not try byte 5. Oh. No. Byte. What do you want from me? Constant byte. That thing 4. 0, 1, 2, 3. Oh, 0, 1, 2, 3, 4, 5. Right. Okay. 6. Wait, that means that when we're referencing 5, 3, 4, 5. No, everything else is still right. See, we're adding the response, which is the 6th byte is actually the timer that has expired. So if you look in the data sheet, the response down here. Wait a minute. Wait a minute. Oh yeah, the length is 5. It shouldn't be 6. And every time we reference it, it should be 4. Uh-oh. Because it's type. Oh, do they? Hold on. Whoops-a-daisy. We may need to do a little bit more implementation here. The event, A0, 1, C, 0. So message class, message ID, and then immediately timer handle. So I have 1 extra in there. So it's actually 5, 0, 1, 2, 3, 4, 5. No. 0, 1, 2, 3. It's actually 4. The length is 5, but there's 4, 0 through 4, which means every time I do timer response, that needs to be 4. That's correct. There's only one place we do it. Okay. That's nice. That's nice and easy. Ew, proprietary BS. Yeah, I know. How do you know when your appendix explodes? I think the coughing and the laughing and stuff is, there's like one muscle that hurts. That's just like right below my rib cage. I'm like, did my appendix explode? I would be the first to know. Okay, 115200, all that stuff. There's our CL and ID. All those things going in there. If boot, serial print booted. Packets, etc., etc., etc. Okay, let's try again. Let's try to compile again. Lower right. Okay, so it's not that. It's just a muscle. It's usually just a muscle anyway. Task declared as array of auto. Hold on. So I guess auto array wasn't, hey chat, look how good you are at programming. You guys told me this would be okay. Declared as array of auto. So we need to know how this thing is storing tasks then. How are you storing tasks? Tell me. Tell me, you useless library. Where are we? We are on the GitHub page for that library, which exists right here. Micros, rollovers, etc. Timer tick, function to call. Return type. What? Function to call at a specific time. Timer at blah blah blah. Function to call every interval. That's the one we're using. Cancel a task. You do that. Auto task. And then he gives you no information about how he's doing it. Handler. Signature for handler functions. T void by default. Unsigned long tick. Unsigned long delay. Handler blah blah blah. Units of time. Calls a handler. Unsigned long time handler T. Calls handler with opaque argument. Cancel a timer task. Task and task. There's no ticks is in long, size is in const, or sorry, size underscore t, bool empty. Bro, how are you doing this? One sec. Yeah, I don't know how to resolve this. I could give it an ID and hopefully it'll, or give it a type and hopefully it'll store properly, but I don't know how to do that. I don't know what to choose. I could give it an int. How is it to, I mean, the task is 0 through 5, right? This bastard calls it auto, of type auto. Auto timer is equal to timer create default. That creates the default timer, and it stores it as whatever the compiler needs it to be. But the compiler has absolutely no idea what the hell's going on. A task value is valid only for the timer that created it and only for the lifetime of that timer. Currently, only a software timer. Any blocking code delaying timer tick will prevent the timer from moving forward or calling any functions. Good. Library does not do any dynamic memory allocation. Okay. The timer, the number of concurrent tasks is compiled at constant, meaning there's a limit to the number of concurrent tasks. The in at every function. I hate this cough. I really hate this cough. Return null if the timer's full. Task value is only for the timer that created it. What does that even mean? Change the number of concurrent tasks in the timer constructor. Save memory by reducing the number of tasks, increasing the memory using having more. Defaults timer mass task. Currently at 16. If you found this project, consider becoming a sponsor. So what the hell? I see no evidence as to the type of this integer or whatever it is. It would be great if I knew it was an integer. I guess I could just call it, I'm just going to call it int and see what the hell happens. We're going to make an integer array of timing tasks, and it might be that it can't cancel anything. I don't know. I'd have to maybe play with the library in order to make it work properly. Here it creates the timer as auto, and maybe if we ran the thing after this, it would work properly. So yeah, timer is auto. This doesn't really mess with timer IDs. Yeah, these just kind of run. We don't know what these are. Auto, task, timer, timer cancel task. You bastard! How do you get away with this? So I guess if I set it to be, let's just set it as an int and see what happens. Where's my code? Int, there you go. I don't know if using auto below is gonna, there it is. Using library Arduino timer master packet CL, oh, capitals. Packet ID. What did I do? Oh, ID is all caps? That's a mistake. Let's find all the capital I, lower D's. Actually, capital I, capital D's. Yeah, here they are. There they are. Lower cases, upper cases, always a problem. Find the next one. Well, you're not even bothering with the case ID, lowercase L. Man, I played it fast and loose with the capitalizations, it seems. Oops. Hup. Okay, good. Looking good. Looking good. All right, that should resolve that. CL, we need to make sure. Lowercase L's all across the board, right? Everywhere we look, it's a lowercase L. I love it. I love it. Oops. Okay, we're good. Okay, I hope this works. We're making an assumption about the type of return from... Why can't I get rid of that? Is there still search window up? No. I can't center click to scroll. All right, whatever. Fine. Keep your secrets, Magic Man. Damn it! I was so confident. Serial buffer. Serial. That should have a space in it. What was the buffer called? Oh, it's input buffer. Input buffer of I. Do it. Do it. You can do it. Damn it. Print in line. Beep boop bop. Damn it. Time stored is equal to serial. Oh, input. Input. You dumb bitch. It's input. What's wrong with you, oh bother? Input. Input, input, input. In we put the buffer. Okay. Input, input, input. Upload. Yes. No! Task! Task was not declared in this scope. Huh? Tasks. Let's call the kitties over. Tasks of packet ID. Tasks of packet ID. All right. It's just little things, all those little details, you know? Just got to get through all this stuff. Time stored, time expired, blah. Time exp is the function, time stored is the number that we just created with our conversion factor, and blah is the ID and etc. that we are passing into the thing so that we can reference it again and get it back out. Yeah. We're terribly sorry, but you have not cursed at the... Wait a minute, why are we declaring this as auto again? Bop! It just needs to be, we're not redeclaring it. Tasks, we're not creating a new array. The array exists. And so we're overwriting whatever's in there at that location of the packet ID with the ID of the timer that we're then going to put back into canceling it. Hopefully the variable type doesn't blow up my entire computer. But yeah, there's a certain set number of curse words that you have to utter with meaning behind it in order for the IDE to properly compile everything. It needs to know you want it. All right, upload, finally. And now it will upload without failing at all. Damn it! Timer.cancel. Invalid initialization of non-constant reference timer. 5U millis short unsigned int. Blah, 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 blah. What did I do? Timer.cancel. What we called it? We call it timer? Timer.tick. Down here, we'll just say timer.cancel. I literally followed the same code that you guys did. Tasks of location packet ID passed right back into it. Maybe I need to do auto. Maybe I need to throw it into a variable before I throw it into the cancel. Timer.cancel to cancel all tasks. Timer.cancel of task. Maybe I need to do auto, like, task ID, or like task num is equal to tasks of packet ID, and then we take task num and we just pass that in to cancel, and somehow that fixes it. No. Shift tab. Control Z. Give me all this. Shift tab. There we go. I don't know. It seems to like really hate the array. So I'm trying to like pull it out of the array and see if that'll make it work. This is still gonna throw. It's throwing. It's throwing. It hates me. Timer.cancel. I mean, come on. Delay function to call. Timer.in. Does timer every not give the same thing? I think it does. Call function to call in delay units of time. Function to call in delay units of time. Argument for the function. Same thing as timer at and timer every. Call at a specific time, call every specific time. Do we not get to do, I mean, if we do timer at, then we'd have to reset them every time. And I mean, I guess we could do that, but maybe there's an error in the code or something. I don't understand, because we called it timer. So we should be referencing the right thing. This would be... I guess we didn't need this anymore. Timer 5 millis, blah, blah, blah. We're just calling it timer, yeah. So if we reference that... Time expired, and then we have our uint 16 of timer number. Time response. Excuse me, sorry. No, most of this looks fine. I don't understand. Maybe their function doesn't work. It just doesn't like our cancel function here. Timer.cancel of task number, and it says invalid initialization of non-constant reference of type timer 5u millis short unsigned int. Short unsigned int and int task and unsigned int from r value type timer 5u millis short unsigned int blah 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 blah. Invalid initialization of non-constant reference. What? Wait, what? Huh? 5u millis short unsigned blah blah blah. I mean, it's not timer.time, right? Or am I getting the syntax wrong? Or am I just messing it up? Ticks equal to timer time. Timer tick void. Voids the ticks calculation. Cancel timer task and task. What's the second part of that? Huh? Yeah, so this is getting out of my knowledge of C++, right? Yeah, you put nothing in the brackets to get it to just cancel everything. But in this case, it's canceling a specific timer. I don't know what the hell this is. So we need to be able to utilize that property. I was hoping that we could reference the ID somehow, but it's like it doesn't want to store it as auto. It doesn't want an auto array because the compiler has no idea what to do with that. Did you make an array of timers? We made an array of IDs, not timers, because each timer is assigned to an ID, and we can get up to 5 of them. But we need to store multiple of those IDs, and it seems like it doesn't want to do that. We have it in the code. The compiler is what's limiting us here. So what it said is invalid initialization of non-constant reference of type timer 5u blah 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 blah, and that would be the function from an R value of type whatever. So I don't know what that means. I don't know what that means at all. We've been trying, because basically when we make the timer, we want to put it into a task array. And I was hoping that, because we have 5 available, I guess, things in our task array, so depending on the number that it's given, according to the packet that comes in, it will be stored in a location at the array. But I don't know what is stored at the location of the array. Timer.everyTime stored blah, 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 returns something, and I don't know what that something is. And if we know what that something is, then we can assign that array to be that something. Let's look at what that something is. Timer, when we start a timer, what does it return? In this case, we have timer task. See, this is where it just assigns, this guy just says auto. That doesn't help me because the compiler hates. Is tasks an array of references? I don't know what tasks is. It might be. It depends on how this person put their code together. I really don't want to get into their code. It's scary. Timer is equal to timer create default. So in that case, hey, in that case, that's what they're doing there. But current task, timer tick, function to call. These are the call to function, call delay, timer. I already read this. They don't give us any other information. And when they say to cancel a specific task, let me get up off the couch and write an example. All right. Because I don't know exactly what I'm supposed to be doing here. It says auto task is equal to timer. You assign the task, but the type you give it is auto. So it doesn't really, I don't know, it doesn't really mesh. It doesn't like me storing them as an array. Because I mean, I could set up 5 variables, but I'd rather not. It just seems to, I don't know. I don't know what it's doing. What's the best thing about Arduino docs? They don't mention types. I mean, you know, typing is very important in coding. I don't know. I've never seen auto before today, and apparently this author uses auto quite a bit. They seem to use it as a crutch almost. It'd be nice to know what their code is returning as an ID, especially given the fact that you only have so many timers, right? He's only got 5 timers. He could set a single byte. Do you have to say auto array? Auto array? I don't think so. Because when you make an array, you just give it the number of entries, right? So I don't think it likes to have a, well, no, that other one was variable audio. I don't think it likes to have a global auto. wonder if the Arduino references at all. Let's see. Data types. Yeah, it doesn't want you to know. It doesn't want you to do that. I could like cast it as an int just to see what happens. That wouldn't work. Are there any comments? Every didn't work. If return not true. Timer ID and callbacks without argument. Replace the function handler. Trigger repeating timer immediately. How do I close the timer? Auto delay timer. Delay timer cancel. Auto task. Auto. It's always auto. What's that? It's upset that you're passing a task object into a function expecting a task and reference, but I thought C++ would just pass by the reference in this case. Some lateral passing to somebody else on this one. I have no idea, man. I'm just here because I don't want to get fined. This is another cancel example. Yeah, we read this one. But this one still, it only stores it as one single variable as an auto. And so I'm trying to get it to store as an array of that, since we don't know what the IDs are going to be initially. Unless we just store it as task 1 through 5, or 0 through 4. Well, 1 through 5, I mean, we could just make 5 variables that would represent the tasks, and then we reference them based on ID. That would require pointers, wouldn't it? What's that, trade? How's it stored now? That's a great question. I have no idea. No, see, it hated this. Task of X. But that would assign every single one to be this one. And you're just canceling 0? Is that just what you want to test? In which case you could install the Arduino IDE. Because we tried that. We had auto tasks of 5. I think maybe because we're not declaring timer with auto settings, it might hate that. Maybe? Or maybe is this the type of the task number? Where did it declare? It declares, this is T underscore timer. So T underscore timer is constant character. Custom handler type. Oh, wait a minute. If I'm gonna reference that, we have the handler type as not a constant character. If I say constant character, then am I making a character array that's going to store the timer ID? I think that's the confusion here. So if I set it to constant character, and then I make this a character array. And then down here, when I store it and everything, that should do it. Damn it. Son of a bitch. Oh, but that's not in it. That's an auto. Char. Son of a bitch. Non-constant reference of type. What does that even mean? What does that even mean? Why does it want a constant? Oh, this is stupid. What is this? 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 Oh, chat, I don't know what to do. This fucking shit. I thought I had a handle on how to mess with these. Like the handler type, I guess, would be the ID number, right? Why would you want it to be a constant character, I wonder? And then it's declared as auto down here, but they're punching it into a singular variable. So, I mean, I could make 5 variables, but you don't need a custom handler. I was told that I need that in there, and that needs to be the type of thing that I'm passing in. But that's chat. I don't know how far I could throw chat and how much I trust them probably aren't correlated, but I'd like to try. How many stories I can drop chat off of and how much I trust them. Where was that? All the way up here. If I get rid of this, what happens? Probably nothing. Of course, I did change everything in character. It's the same error. We still don't know. We still don't know what the hell it's doing with this. And again, the error is invalid initialization of non-reference of type. And then the type millis task, aka unsigned int and from our value of type unsigned int and versus unsigned int. Yeah, I mean we'd start with like maybe we should start at the top of the building and then we'll work our way down and see what happens. Yeah. Can't cancel a task like that. That's literally how they told me to do it. That's how they told me to do it. That's the example. I'm following the exact example. Unless this person's like creativity and coding is so limited that they can only imagine that you would store and then immediately cancel a task. You read bad. Yeah, classic programming stream indeed. Constant struct. Reinterpreted cast task. It's not a number. Okay, so what is it? It's a struct. I mean, they hide it behind auto, so I don't know. So how do I gain the ability to start and cancel a task based on ID number? Because I'm figuring that ID number is only going to be 0 through 5, right? 0 through 5 ID number, and so we can reference that in an array. Uint t. What? Well, task is defined as like I showed you in the example. I think you guys overestimate my ability. Okay, you're right. I'm bad at reading, that's for sure. It would be nice to have seen that in the example. Timer.cancel of task, whereas we need tasks of the task array of blank cancel as a reference to the timer. But the timer is in a certain ID. I see what you're doing. Okay. So I see what you're doing. Because if we reference it as the timer, what did I call it again? What do I call that thing? And then I need to make sure that I'm storing it as the right thing. I don't think I'm able to do auto Is it uint? I don't even know what PTR is. Uint PTR? Somebody else said it was stored as something insane. You store 5 tasks in set array. If I set it as auto, yeah, see, that's why I was confused. Timer. So you were wrong. But yet you guys put the hurt on me for it. Uh-huh. That feels good. Thanks. Thanks, chat. Anyway, let's so it's not supposed to be like that. Okay. I thought you were being very clever in that would reference that timer thing, but I think we've already declared timer as timer, so we need to timer.ba cancel, and then task num is task of packet ID. I think I called it task, not tasks, right? I always do this. I gotta go all the way to the top and then all the way back to the bottom. Hold on. All the way to the top. It is tasks. Timer cancel tasks of, and then that would be packet ID, because packet ID is just a hexadecimal that represents the position in the array. That's what we had before. This is what was in the code before. So if I run that, we get the same exact error, because tasks is declared as auto. Now, we're trying to put an array in sort of the path of this code in order, and maybe it doesn't like the array being there. I mean, we've pretty much established that. It doesn't like me declaring it as auto. You think it's unsigned int and then a reference? Can I do that? I don't know if this works. This seems weird. Oh my God. Actually kind of got through it. I'm just not doing something right down here. It's an array of timer 5 millis task. Yeah, what is that? That's a struct, right? How do I make an array of structures? If I store it as int locations, is that what I'm trying to do? Yeah. Yeah, because it stores it as the whole thing. Just put the type caret. Boy, I don't know what that means, man. I'm playing Dyson Sphere Project and listening to this, and I need a nap now. Yeah. If I define the type as timer, what, timer dot tasks or something? Wait. You guys seem to like stop giving me the info. Put all that as the type. At the top. So you guys give me these little snips. You're not This has been what I've been dealing with all week is when somebody doesn't get a complete bit of information and they don't know what's going on, they inevitably pivot and get it completely wrong. And so I've been dealing with your end of that, is giving these little snips of information, thinking that you're building up knowledge of a dialogue, because I'm scattered. And so each message is on an island. I'm trying, chat. At least now people can see the dialogue going on here. If it is of type timer 5 millis task as the entire, that doesn't seem right, man. People trying to give you glowy brain advice. I know. Of type timer tasks. But I'm only defining it down here. Or, well, I'm assigning it down here. Just time. Okay. 2 pieces of advice. We'll try the simpler one, but I'll put everything in if it fails. Oh shit, I hit upload. I should have hit verify. Well, lucky for us, it failed. I can tell you right now, it's not going to like that. Oh my god. Oh my god. Did it actually like that? You know, maybe I need to move this up. Do I need to declare timer 5 millis task, etc. Up above? That fucking worked? That worked? Crimson Dawn is made of weirder material than the rest of us. I can tell you that right now. How can I make this make sense? Please get out of the way. If I move this up or I move this down. So now maybe all I need to do is timer or it makes no difference. If you declare task 5, you're allocating and creating 5 task objects on the stack. If the library is initializing and returning them, then you want task star tasks 5. So if I do the initialization first and then I just do a reference or whatever the hell that is. Assuming it's a class and not a pointer. Do I need a space in there? You need the whole thing, unfortunately. Yeah, it doesn't like it. Yep, it's not a type. Wow, why is that so gross? And I guess that's why they said auto. What if I declare it as auto here, an auto array now? Nah, the compiler still doesn't know what to do with it. Yeah, so it just doesn't like that, huh? That's wild. The template creates the type of the compile time. Oh, we should add an easier name. Yeah, that's a weird one, huh? All right, back into some kind of working mode. That's so fucked. That's so fucked up. The auto keyword should be banned. See what I'm talking about? This is like earlier, Wexo was like, auto is fine, nobody cares. And I'm like, hey, every professor that I've ever had for programming would probably like murder you with an axe if you used auto on things. And it's like, no, it's encouraged. But then we have people coming in and going, the fuck, ban that. It's whatever. It's the examples that I'm getting on this library. Yeah, so this gets into stuff that I don't understand that Chad has a much better handle than me on. It is encouraged. You can type anything you want into chat. You can type anything you want into chat, mostly. But I don't believe you. All right. That's kind of fucky, isn't it? I don't like that at all. Any recent C++? That's so weird. That's so weird. I wish there was an easier, like a more intuitive way to do that. I guess as long as they're one on top of the other, it might be all right, but it's just kind of crazy, right? I mean, I guess I could define that as something and then reference that, whatever. Reference the location of that in order to... all these weird, dumb... I don't understand references and things like that in coding. It takes me a little bit of review every single time I use or alter code with that. Every time. So I guess I'm going to leave that in there. I hate it, but I'm going to leave it in there because that creates the proper type of array for us to continue on and to store with an intuitive ID number, 0 to 5, what that entire reference to the timer is. Yeah, I don't know what the deal is either. If auto can't handle whatever the hell this is. Can't type def be used to avoid the duplication? I don't know. There's no way to recall the number. There's the number of timers that you can get out of the thing, but I don't think you can get like a specific ID based on number. It would be nice if we found a library that almost does exactly what this one does, only it had ID number references. That would help us a lot. But in this case, we don't get that, so we have to make that. So that's what we're doing here. I don't understand exactly what's going on. The data storage in memory needs to be defined as something. That's what your whole typing is in the microcontroller. And so in this case, our typing is like a structure of things. And so we need to like put that together and make it into something that can be referenced like an array, I guess. I don't know. It's a weird thing. I don't understand it, but our code will hopefully use it. 3.14 versus 6.28. It's a fight. Yeah. Yeah, it can't infer it from context, which is odd. If only I could do like timer.id. That would be very functional in this code, and maybe you could brush a bunch of that stuff under the carpet, you know, put it into the other parts of the library. But we're stuck doing this. It compiles like this, so clearly we're doing something correct. All right, let's get this onto the microcontroller though. So I'm just gonna verify it again, just make sure there's no little stupid mistakes that I left in. Beep boop pop, everybody's ready to go. And so now what I can do is upload this to the Arduino, and then we can boot up the thingamajig. We can boot up the Granite Devices controller with the serial monitor open, and we can see what kind of a serial printout we get. Now keep in mind, with the previous versions of this code, I was able to get to what I called 5, right? Templates always mess me up, but I'll give it a shot. Timer, the brackets, is a template, meaning it generates a thing at compile time. That thing also creates a type that we need to reference. Is that really what it is? Because creates the type that we need to reference, but it doesn't create until compile time, then why doesn't it stand a reason that I would be able to reference that type after it creates it? I mean, does it like vary, or can I use some of the suggestions before that people said it's like a uint type def task T or something like that? Like if there's a fixed type, I keep using that word. If there's a fixed whatever, like variable declaration that I could use, like byte or char or uint 16 Venus. That's what I'm doing with this word salad. All right. Well, weird. Weird. Definitely weird. So let's see what happens when we upload to this thing. I don't want to do this. No, I do want to do this. All right, I'm going to hit upload. That's going to go into the Arduino. Then I'll open up the serial monitor, and then I'll boot up the Granite Devices controller, and we'll see where we get to. We're done. Serial monitor, nothing is happening. That's good. That's supposed to be. So now, you could technically use uint PTR. See, I don't know what PTR is, but I'd use that if I can. Let's see what happens when we boot up Granite Devices controller. We're all hooked up to receive everything. I haven't touched the setup. Hey, look at all this stuff. Guys, I think we got everything. It doesn't look like we got all the packets, though. Turn off auto scroll. I think we got pretty well on. It looks like we are currently in... Well, we're not sending the RSSI back like we... Oh, we are. We are. We're sending this message back just like we should. We are in waiting mode. I think we did it. It's weird that it did this so quickly, though. Okay, so I still haven't gotten a beep boop beep from the controller, though. Or did I? Did I miss it? I might have missed it. I didn't hear a beep boop beep. So what happened here? We got the command system reset. We sent the event system reboot, set bondable mode, store bonding configuration, set software timer ID, and then it immediately jumped into the RSSI stuff. We didn't see any other commands come out. So something might have happened here. But this is like the waiting mode. It didn't configure anything else. Same as void. Would that not work? Integer large enough to be castable to pointer, yeah. Uint pointer, is that what it is? PTRT, okay. Pointer of unsigned integer, weird. Store bonding configuration, software ID, and then we just are jumping into the regular get RSSI. Software timer ID 0. Why is it pushed all the way over there too? Why are there like 10,000 spaces ahead of the 0? What is happening? It usually sets timer 2. And yet somehow everything appears to be working correctly right now. That's weird. I think there's an error in there, but somehow, because I got it to go through 5 stages instead of just a couple. So I think maybe our timers are being stored weird. But yet, on this scope capture, everything looks good. That's very strange. Is it 1/3 of a second between pings? That's the other question. Put on some cursors. I mean, I don't think I got the boop 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 of a full ready signal. But it does keep asking for RSSI like it normally does. And we're doing 500 millisecond replies. Almost an engineer. Thank you for subbing with Prime for 21 months. I really appreciate that. Yeah, 21 months, man. Thank you. Yeah, timer ID 0 is not correct. I don't know what's going on with that. So let's investigate our code around timer ID 0. Because we get to the first timer setup, and we see the appropriate amount of time passing. We see about 500 milliseconds between, 500 milliseconds between us telling it that the timer's expired. But we tell it the timer's expired first, and then we somehow get a tell me the RSSI. And then we send it a we got your RSSI. So hold on, let me zoom in on this signal. Zoom out on it a little bit. And stop the scope and see what it interprets as having happened here. $6181FF. What? 6181FF? That's not an RSSI request. There we go, 2181. I feel like sometimes it gets this completely wrong. 21 sending, length 1, 81, and then FF is the signal? Ugh. 2181. So we're looking for 81. And it should print it out if it doesn't know what it is. F2, 35, F1, 0318. Let's check our notes here. 318. Do we ever do an 8-1? I think we don't know what 8-1 is. There it is. 8-1. Get RSSI. So then we send the send success, send RSSI, and then we wait for the next packet. Why is it asking for the RSSI at this point? It should be doing more stuff. It didn't do any of the other stuff this time. So what's happening is we do system boot, right? First it tells us to reboot the base, command system reset. So we got that. We send the event system boot after a certain amount of time passes. That's just hard-coded. That's to emulate the BGM 111 restarting. Command set bondable mode, and I forgot the space in there. So system boot, command set bondable mode, MDSM store bonding. It should be command. No, it shouldn't. MDSM store bonding. Hardware set soft timer ID 0. That's not correct. Handle should be 2, and it should be repeating. But it still is properly coming through. But I guess it's not giving the right ID back. That's what it is. It's sending the wrong ID back. It's saying a timer's expired, and so the base station is saying, what's your RSSI? And then we respond with the RSSI, and then we go, a timer's expired, and it goes, what's your RSSI? It's like, why am I not getting the right timer ID back? So it is an error in the timer ID, and it reported it as 0, so we need to see what happened there. So where are we putting in the ID? The timer's setting up correctly, though. That is actually happening correctly. Oh. I'm taking the wrong number. That's what it is. The timer ID is the array position 0. Array position... What parade position? Wait, it's the array position... It's not the packet ID. I've been taking the packet ID. I think I took the wrong ID. The ID. The ID. The 3D, 40, 3D, 3D3. Coexistent static counters. Result code. Response. Message ID. 0 or non-zero for error. Where are we at? Coexistence interface. What is that crap? We're looking for the timer ID. I think I have this open in another window. I wouldn't know where it is. There we go. Timer handle. That's not that one. Here it is. Message ID. That's the wrong one. That's the response. Okay, yeah, here we go. Command. It's position 8. So it's actually position 4 in the array. Because we subtract the first 4, because we store these as variables. 0, 1, 2, 3. So 8, 7, 6, 5, 4. So it's position 4 is actually the ID. High byte of timer number. Yeah, well, that's okay. We were okay with that. But we're looking in... Would it really be position 4 of the... Position 4 of the buffer. So when we store it, we're looking at the input buffer. Let's get packet, print packet, send success. Set the timer. It's not 8, it's actually 4. And then this one is 5. Because the input buffer is -4. So that should fix it. And then 0, 1, 2, and 3. So we forgot to do the subtraction on these two. So that might fix it. Let's try. Upload. Upload it again. I'll put my O-scope back to where it was. And then we run. Actually, it might suddenly respond to the things that it should. No, it needs to be started up again. All right, so here we go. So power off. Pew. And then power back on. Boop. Haha! There's all kinds of numbers floating around, but stuff is happening. And we booped. Yeah, we booped, chat. We did the boop. I'm not seeing any serial on the line, though. There it is. Let's see if there's anything going on here. Oh, it looks like it did stuff a couple times. Wow, it did it a bunch of times, actually. Something's wrong. Something's still wrong. Timer stopped. ID. Her timer ID. Oh, no. It's trying to do a bunch of stuff. Over and over again. What the hell? It doesn't look like it's trying to do all this stuff. Huh. ID is equal to... Why is it 2-0 and not... It should be 0-2. You think that's why? Let me put another parenthesis in there and see if it cleans it up a little bit. Power off. Ugh. Getting closer and closer. It's just that timer thing. The references could be a little bit better. If you've got only 5 timers, why reference it as that entire thing? It might clean up your code on the back end, but nobody cares about your back end code on the library. That's what I have on all of... I have it on all of them. Oh, it should be 2x. I didn't see that. Makes more sense. That would explain the 20 zeros. I have a split second to look and interpret what people have typed is, so it helps if you make it really explicit what I have to do. All right, so that might fix that printout. Serial started. Turn it on. Bunch of stuff. It really shouldn't be that big of an ID. Why is it 4? Okay, so we're in an error state. We keep repeating stuff. So what happened? So we're getting close. Man system reset. We sent the boot. Set bondable mode. I'm going to fix that space right now. Set bondable mode. Where is that? All the way up here. Set bondable mode. We'll do that. Save that. Set bondable mode, store bonding configuration, timer ID, and then it's 020033. What the hell is all that? We should just be outputting like a short thing. It should be like one number. It should be 2. Why is it all that? Well, let's look at the prints. So set the timer. Serial printf input buffer of I. Oh, no, this is the wrong one. Sorry. That's the wrong area. We're down here. Timer stopped ID. Or no, where am I sending the... Maybe the packet ID has changed a little bit. No, this is the timer stopped. So if a timer stopped, and that's a receive timer stopped, receive timer stopped. ID is equal to 2 characters of the packet ID. And then I guess after that, maybe we receive something we don't understand. Because we shouldn't get to this. Command hardware set soft. Let's see if maybe the return isn't working. Oh, that might need to be a break. That might need to be a break. Maybe that's what's going on. Yeah, that needs to be a break. Because we're returning from the... No, we should be returning from set timer, right? That's not a break. If that was a break, then it would print out the next piece right there. That appears to be what's happening, though. That appears to be what's happening. Something in our loops are fucking up. Brother, the loops. I mean, what's funny is that we could almost operate like this, and maybe we could give it the information at this point, and it would still respond to it. But I do want to get through the entire configuration. We get start discovery, and then we get a timer stopped. The TT2 is the same. TT2 is a bruiser, man. It's a nice chip. We're using TT 3.2 right now. Command hardware set soft timer ID 0. So it's still not getting the right ID for that. But when it prints the ID, it prints 0, and then it prints 4 characters. What is that about? Why are we printing 4 characters? Because we don't recognize the next command? Or what? We don't know exactly where things are going. Packet ID. And packet ID is just a byte. It shouldn't have anything else that it can store. Yeah, it's got to be from somewhere else, right? But without spaces too. 33020. I don't know. Maybe there is a command in there or something, but also the timer ID is still not setting properly. We need to make sure that it goes in there properly because it should be setting timer number 2, but it's not. That's part of the problem. That's part of why it's messing up all over the place. And maybe that's also why we're getting a printout of God knows what from God knows where at the end of this. It could be that maybe there's something that maybe it doesn't recognize, something's not going into the right spot. So somewhere along our prints, it's just blowing out these numbers. Because technically, I mean, we should print the ID and then get out of there. And when we get out of there, we've got 0, 0, which doesn't make any sense. So let's roll through the setting of a timer. I'm going to power off so we're not confusing the poor serial output. Yeah, somewhere else in the code without a new line, we have some kind of a printout going on. Which might be, it might be default. We might be hitting up against default down here. That might be the beginning of something that it doesn't recognize. Some kind of a, if it's a 20033, that actually this might be our code working properly. What does 33 represent? That was a 320. Oh yeah, we don't just want that. We want, and then we want 0303. 3C, 3B, 3A, 313, 326, 31, 32, 321. That's 3D. The end procedure. What have you done? So I need to add that to our possible packets. Not that, I mean, the set gap start discovery 318. We might not ever run into this case if we get it running properly, but case 0x33. And then we can set that as command legap end procedure. Sned success. We want to print the line. Received command legap end procedure. And then we want to clear the packet, obviously. And then we break. We break. Send success does not need to know the packet. We don't need to add that to our packet array. It doesn't need to know it because it's taking the IDs before we clear them, and it's just putting them into a successful receive packet. So actually, we are going to auto-generate the response, which is 233, and then a result code. Oh, wait, no, we need 4 and 5, huh? I think we do make that, because all of them have that result code in there. So we just give it as zeros, and it's fine. 20033 is in your capture. Did I just not put it anywhere in here? Yeah, I didn't implement it yet. Okay, well, now it's implemented. That's all we need to do. And then ask for an RSSI. But then we didn't do some of these other ones. We should have more commands in here because our our half a millisecond timer isn't properly configuring itself. We're not getting the right number. Excuse me. Whoa. Whew. Man, fucking stomach hates me, man. Can I do print line F? Print F. Print F. And then we're doing it in... Would it be %4 X? And then it's bleh. And that's in quotes. And then just print line. New line printf is, yeah, I don't want to do that. I don't like doing that. I like using my print line statements. I don't mind a big serial print. I'm not afraid of it. Not afraid of it. I ain't got no fear. Hey, my glucose level's finally normal. Finally, I can drink liquids without it immediately going into my bladder. Yeah, 20033 is somewhere in my capture, which is pretty crazy. We got to check over our math on this timer. I think maybe that's where most of these are. This is a game changer for me. I just print the number of remaining spaces so it wraps. I used to do that. You do that on displays a lot because displays don't like play well. So you can make your own display buffer that just like stores the appropriate number of characters and then buffs the lines. I used to actually have it print zeros when it was a hex 0. So the printf thing, people teaching me printf really, that really helps me. So now we can actually print the whole thing for the uint16t. So what that'll do is that'll tell us what we've created by storing the timer ID and stuff and see whether or not I fucked it up, basically. This is positions 4 and 5 in the buffer. And it should be 0, 1, 2, 3 is the timer time. And then 4 should be the ID, and 5 should be whether or not it repeats. So I don't know why bleh isn't coming through properly. Let's try it. Once we get that all figured out, it might... What? What do you mean? What do you... Oh. Pop. Okay. You son of a bitch. Can't believe you've done this for me. To me. Break. Boop. It's getting windy outside. The rain should be letting up like later tonight, but goddamn, it feels like October out right now. It is breezy out there. Holy shit. Which means the power might go out, so we'd actually be able to test the generator. How's that? How's that, huh? Although the power's been very stable lately around here. It almost makes you question about whether or not you should go and get a generator. Wait a minute. Well, it's very nice and it started up anyway, but it's still having trouble initializing the module. I can turn this off again. Okay, so yeah. Reset, boot, bondable, store bonding configuration, 0200. So we are getting the right data, but then set timer ID says 0. Something's up here. Do I got the wrong thing printing? Or did I set it all correctly? That's the question. Packet ID. Packet ID. Packet ID. That's not... Packet ID isn't the... Packet ID is connected to command. Yeah, packet ID is connected to the command. And the command for the set timer is 0C00. Bum, bum, bum. So it's actually input buffer of 4 is what I need to be putting into those locations, instead of packet ID. Anybody else? Anybody else trying to do a packet ID when they shouldn't be doing it? Yeah, you do right there. What are you doing? All right, there we go. So now that's going to put in the appropriate thing. Timer ID that. Timer stopped ID, input buffer 4, input buffer 4. And then that's stored in uint16t input buffer 4. All right. No, it's not the Eddianness. No. Yeah. I'm not calling it the Little Indianness, even though the original author, Gulliver's Travels, might have meant it to be like that. Might have meant it to sound like that because of the little 10 Little Indians kind of thing. I like calling it 10 Little Indians thing. Sorry. I like calling it Endians and just getting the pronunciation wrong. And therefore avoiding controversy. All right, ready to go. Upload that, and then we'll see what we get on the serial monitor. We should be able to proceed a little further on now. ID 2. Something happened. Whoop we go. All right, store bonding configuration 20, software timer 2, command gap end procedure. Then we get the timer in again. Connection parameters, bondable mode, bonding configuration, set soft timer 2. We can get rid of this extra printout. Get rid of the extra printout. That'll clean it up a little bit. Uh-oh. And we'll restart and see where it gets to. Restart it all. We'll see what we do. What we're doing wrong. What are we doing wrong? What could it possibly be? Yeah, BLE is used in order to pull back out the repeat of the timer. I mean, I could use it in order to define whether or not the timer runs multiple times within the timer library, but I need it to expire, and then I need to do stuff when it runs that function. I could probably just look at the end of it. Given that the argument was about which end of a soft-boiled egg to open as a parody over the question of which need to bend to a senior member of the ecclesiastic hierarchy, I somehow doubt all has much to do with the subcontinent, but I'm willing to be convinced. Man, listen. I'm avoiding it. I'm giving it a big berth because we're not necessarily talking about whatever. Anyway, reset, boot, bondable mode. store the bonding configuration, soft timer ID number 2, command legap end procedure, set software connection for the SM configure, discovery. Is the timer expiring? It's not expiring. That might be the problem. Yeah, our timer isn't expiring. That's the problem. Ba-da-dun-da-da. That's the issue. So our timer never expires. I mean, the other way to do it would be to look at this location and see whether or not hold on. Hold on, let me just define something here. Okay, whatever. Whatever. All right. We have 2 parameters in here that I was putting into the function call. And the reasoning behind that is to see whether or not it's a repetitious timing event. We don't need to care whether or not it's repetitious if I use the non-repeating timer. So if I set a timer as not repeating when it is defined as not repeating, I can get that out of this input buffer and turn that into uint8t and not have to have further logic over on our function that runs when a timer expires. I don't know if I want to do that though. No, I kind of want to do that because I think that's the better way to use the library. Now that we're a little bit more familiar with the library, I kind of want to implement that since we are currently trying to vet out this piece of the code. So if we're vetting out this piece of the code and we look at the GitHub stuff about how to use it, we need a timer dot, where did it go? So timer function to call in delay at specific time every interval. So what we do is timer in if that is set to 1. So instead of all this, we're going to do uint8t. So BLE is just equal to input buffer 4. We don't need to mess with that at all, because we're just using input buffer 4 when we call timer cancel, timer stored, tasks packet ID, timer every, timer stored, temp expire, time expire, and then the BLE is the ID number. Does it even need the ID number? What's that, Frisk? I think I've seen you before on here. Is the direct drive a ready-made specific brand like Simucube or some industrial bare-bone direct drive motor? The Simucube is the motor controller, and that uses the Granite device motor controller like system, and that can use a variety of different motors. They call it the Swiss Army knife of motor control, right? So the direct drive motor, you can use a variety of different motors, and that's what's so great about the original Simucube. Now, Granite Devices has moved on, and they have a Simucube that is strapped to a motor that they have designated. And so they control a lot of the stuff that's going on with that. The original Simucube is built up on the backs of the Open Wheel project. And so this provides you with STM32T and a motor driver, which slots in like a card, and it allows you to move all this stuff. It allows you to, get all this stuff moving. What's up, Ben Sai? How you doing? I'm good. We're getting through. We're stepping through the process. We're stepping on this thing. We're getting it working slowly. I think what we can do is, because if we task and we reference the ID, that's fine. We can then do a periodic if it asks for it. So if, and instead of doing BLE, we will just put in input buffer of 4. What are we doing with that input buffer, though? Let's find out what we're doing with that. Time expire. If time expired... Timer response. Oh, we're putting that into the response. Oh, okay. So instead of doing high byte, we can just do timer number. We'll make that a UNT. If low byte of timer number is 1, return 1 and 0. That's just canceling it. If we're canceling it, sure, you've seen my name before. I followed since 2018. Yeah, that's right, Freeze. It just seems like a weird, it seems like a first-time question. I'm like, wait, I know Freeze. Reviewing the past 4 years I've been on Twitch. Oh, I don't even want to look at that. Wait, hold on. How are we canceling the timer? Because that's like, if we return from the every timer event with a 0, we cancel it. We never need to do that. We're canceling it from the cancel command because we get it setting the timer to set to 0. And if we set the timer to 0, then we're trying to cancel it from the cancel command. So we don't ever need this. So we can always just return 1. We don't need to mess with this. We can simplify our functions a little bit here. I don't need all the information anymore. So timer response is timer number. Then we send the entire packet of the timing response. And we are replacing position 4, 0, 1, 2, 3, and 4. And then that's the command that comes back. And then that says, hey, the timer expired, right? When it wants to cancel a timer, we then look down here at this piece of logic right here, which looks to see whether or not this thing is equal to 0. And if it is, we cancel. And then we feed tasks the number that we've used to store the information about that timer. And that'll cancel that timer. I really wish this library just used numbers, you know, instead of giant references. I feel like this return isn't working, and that's what's going on with our timer. Our timer has not been triggering. So I think we need to print out what the timer is. And so BLE is no longer a variable. Let's get rid of all of this. And now we just have our input buffer position of 4, and 0, 1, 2, 3 are what the number of ticks are. So let's print out what that storage is. Because if it's, I mean, it's not initially canceling, right? Reset, boot, set bondable mode, store bonding, oh, I need to add a C to that one. Hold on, let me get a little bit of, let me get something right here. Command set storing bondable configuration. Bonding configuration. So all we've done is we've created an engine that gets data in and is able to then fake that something has been set. We're not actually doing anything with all those commands. I have named them so that we know where in the process of booting up we are. I don't even really need to name them. It seems like I just need to set like an array of values that we then respond with like a packet. But then there are some that we don't respond to. So there's some we don't respond to, and there's some that we set, like for instance the reset command, we would just throw back a boot status. Then again, we send an OK for literally everything else. So we could just build this into like a fixed engine that would just automatically say a response to something, and then if it gets 1 or 2 specific codes, it'll then say more. I didn't think about that before, but we've already written all the other codes, so it doesn't matter. We've already done all this work. What's the point? So I'm gonna do, let's just print the time storage. print line, and then I'm gonna put %, and then it's gonna be 2468 X, and then input buffer, no, time stored. There you go. And we'll just do like we'll just be nice. We'll do serial dot print, and we'll just say, hey, hey buddy, this is the time. No, let's do T. Just T. We'll know what T is. All right, save that, and let's upload it and see what happens. Let's see what we're storing, if it makes any goddamn sense. Oh no! Oh, printf. Printf. Serial dot println. Beep, bop, beep. In it goes. Damn it! What have I ever done to you? Oh. I forgot a bracket. I can't believe you've done this. Upload. We're getting there. We're getting there. We're kind of doing a shakedown in order to make sure that everything works. So let's just see what happens now, and we'll be able to see what the timing looks like that we're trying to store. Or if my sudden rewrites work at all. Beep, bop, bop. Bonk. Interesting. Why are we getting multiple timers in here? Timer stopped, ID 2. All right, so that gets turned off again. We can now look through our logs to see what the hell's happening. So, command system reset, we send the boot, bondable mode, store the bonding configuration, and then time that's stored is 4,000, which is indeed half, it's a 0.5 milliseconds, right? Hardware set soft timer ID is 2, and then we get a gap end procedure back for some reason. Abominable mode. And then it sets a timer of 2. Connection parameters. Wait, this is good. Wait. This is part of the booting. Hold on. This is part of the boot sequence. This is good. So is this in order? Is this the order that we got? Wait. I think we got it to the next steps. So we are in hardware set timer ID 2. So we start off system boot, then we get to the 3 back and forth comms. Bondable mode, bonding configuration, soft timer. Bondable mode, bonding configuration, soft timer, and then we're just printing that out there. Gap end procedure. Don't know what's going on there. Soft timer goes off. Soft timer goes off a second time. And then gap end procedure. Goes off, gap end procedure. Timer, connection, configure, start discovery. Device in wrong state to receive. 223381.1. So we're probably getting that, and we just don't know it. Yeah, I think we're in idle mode. I just don't see any of our timers expiring. We didn't put something in there. I think we're doing everything correctly. Print. S. Timer expired ID serial printf quote percent 20 x percent. I'm learning it better and better. I hate that I have to crouch down in order to code. I need to be like this. Percent, and then we're gonna put in a time number, even though we don't really need that. We don't really need that variable here. Oh, we got it. Time number. Because we're always gonna get the cancel packet and it's always gonna be loaded up. So I can just replace it with timer response. Yeah, I gotta leave it alone right now, but I mean, to be honest, we don't need to pass that in there. We can just say stop the timer. But oh well. Or you know, expire the timer. I don't need to pass that in there. Oh well. It's whatever. It's more malleable code if we need it, I guess. But all right, so that'll give us the timer number, serial.print line. All right. This is that advanced shit that people come to a bother for. And yet, he doesn't even know what he's talking about. He barely even is able to reverse engineer stuff. Does he know that he is wrong about everything, including his variable names? Timer number. Upload. Let's go. Damn it. What did I do this time? 20. Oh, yeah, 02. 02 and then no percent at the end. Why? I typed it all wrong. Print F. Print F. Print F. There we go. Upload. I got it. You guys don't need a backseat on that level. I am capable of looking at the line that is read it out and figuring out which what variables need to go where. Serial started. Let's see where we get to. Bop. Bonk, bonk, bonk. Oh, we're still printing out our timings, but that's okay. Dude. We're getting multiple timer expired, huh? I don't know if it's able to stop these timers. They seem to be injecting in here. Huh. Look at this. Timer expire ID 2. Timer expire ID. End the gap. Set software timer 2. 2. I mean, we did cancel it up here, I guess. Store bonding configuration. Software timer ID 2 is 4000. Timer expired 2. Timer expired 2. End the gap. Set 2 to a different parameter. Oh, we need to, if it's already been set, we need to send it, we need to cancel the other one. We've got multiple timers going at once, and we have no means by which to cancel it because it's rewriting. It's trying to rewrite the timer ID. So let me see here. If we've already seen the number, if the ID contains anything greater than 0, we need to cancel that ID and then set it to nothing and then reset it. We need to cancel that ID and then start it again. Do I need to actually keep a timer active array? I think I might need to keep a timer active array. Or because it's not necessarily going to be 0, right? It's like a referential thing. It's like a weird thing. So I think what I need to do is when a timer's set, I need to have a Boolean array that I set to see whether or not that is active. And then I can cancel the active timer and then restart the other timer. That's what it is. Okay, so we need a bool timer active. I'll give it 5 entries, not 56. False! 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 Ah! I like typing that. 1, 2, 3, 4, 5. Yeah, that's correct. Okay. So we got 5 timers in there, and we can see whether or not they're active. So what I can do is check to see if bool timer is active and then cancel it. So what we need to do is, if we're starting a timer, that would be all the way down here. False, false. All the way down here. 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 There we go. Set timer. So first of all, is timer active? So we need to do if this would be input buffer of position 4 is equal to, no, 4 something or other to something or other. Wait a minute. No. We know the input buffer is already addressed. If input buffer of position 4, if the array of position, oh God, yeah, I gave up on classes, but it's this whole world of hurt. We're using somebody else's library right now, and it's causing me early gray hairs. We're using arduino-timer, and we're almost there. I'm getting real close. We have an array that's doing this insane magical reference bullshit all the way up here. A lot of these are actually not, we don't need these, to be honest. But anyway, over here, I have us, like, registering a millisecond timer, and it has a possible of 5 entries into it. But we don't know what the hell the library is doing with them. So in order to make a task reference so that we can cancel them based on ID number, we have to define the type as this, which is the most insane thing. And then I have like my boot bool, and then this is the function that runs. But in addition to that, I'm just now adding an active timer array. False, false, false. Active timer array that's going to tell us whether or not we are already using one of the ID numbers in the array, and then I can clear that ID number before we rewrite it. Absolutely psycho. But I mean, this is just how it works. I could probably program just an array countdown timer, and that would do the same and be a whole hell of a lot lighter than whatever the hell we used. It was supposed to make things easy, but it seems like instead we just need like a timer update task and to see whether or not something equals 0. We probably could have done that by now. But we're like this close to getting it work, so I'm just going to write this function that checks to see whether or not the input buffer has a Boolean value that says that it's set. So if input buffer, no, it's active. Hold on. I got to think about this. So we're looking to see whether or not timer underscore active position of input buffer position 4 is true. And here we would reset, we would cancel the timer and reset. So in order to cancel a timer, what are we doing? Timer cancel input buffer 4. And that's it. What's up, Athenor? Oh my God, I'm going to take a shit. This is ridiculous. So the task reference is by ID, which is an input buffer 4. The timer active is by ID, which is in position input whatever input buffer is. So if timer is active, we cancel the timer, and then we overwrite it in the following code. We also have to make sure that timer active of input buffer 4 is set to 1. But if it's canceled, then we're setting timer active position input buffer 4 is equal to 0. Oh my god. Okay, so there's it set to 0. If we set it, then timer active position input buffer 4 is equal to 1. So that's just a Boolean that's going to tell us whether or not this thing is active. God damn. Just put it into a damn variable. I know, that's what I'm running into here. I didn't expect this, all right? This code is built up to this level. And actually, what's funny is that this entire section up here, all these cases are just useless. I could just like make an array that would then do the same thing, because they all do the same thing. We just have different commands IDs that are being printed out. But I've already written the damn thing, so I'm not going to unwrite it. It's just extra memory. Define it. No! Oh my god, you guys are sadistic. All right. Upload. Now that's just going to put a little logic in there that's going to set whether... Damn it! Oh. Input buffer. Input buffer. Input buffer. That's just going to set whether or not we have an active timer in that location. Because if we already have an active timer, we'll clear it and then we'll write it again. That way we don't have two more. Because that actually registers a new timer somehow. And then we lose the reference to the old one. So we just need to make sure that we're able to deactivate it. Is that correct? Yeah. Yeah. Because then it'll overwrite it. And if it's stored as 0, it'll try to end the already active buffer. Wait a minute. We're telling it to set the timer. So we need to check to see whether or not it's 0 first. Cancel the timer. Otherwise, if we don't cancel the timer, we need to check to see if it's active. And if it is, we cancel it. And then we move on. Otherwise, we return. We cancel it, and then we get the hell out of there. Whew. Oh, yeah, no, I mixed snake and camel case. I don't know why you guys think that they need to be kept separate. They don't. And I also use 2-letter variables, and I also use I and J, and yeah. This is going to be fun to debug. I've already done quite a bit of debugging on this. If you would like a copy of the code as it exists right now, in its pristine and perfect working form, I will right now upload it. I'm that confident. Actually, this thing's probably going to fail every way right now, so maybe I shouldn't upload it, but I'll do it anyway. I'm going to delete the old one, and I'll throw the new one into the Discord. We're gonna work like kind of late tonight. I want to get this done. At least the communication part of this, right? And then we're this close to getting it up through the entire boot sequence. Right now, what's going on is that our controller has too many timers active. There's all these timers active that are going on. We need to have them logically cancel when they're overwritten. So send me the Simucube and I'll debug it as if. All right. Upload. Any other little grammatical errors? I saw some red text in there. Well, it looks like it went through. Serial started. Boot up and see if we can do this properly. This is where something goes horribly wrong. Yeah, we've still got the timer expiring, the wrong timer expiring. I think. It looks like timer 2 is going off, yeah, too often. So we're not unsetting it, huh? Let's turn it off and give it a break. Okay. Hardware ID of 2 is being set at 4. Expire. End the gap. 2 is being set at 2. Expire 2, parameters, expire 2, configure, expire 2, discovery, expire 2. something is wrong. Time is set to 0. ID2 is stopped. Then timer of 2 expires again. What's happening? What's going on here? We're getting something wrong. Did I not cancel the timer? Cancel tasks input buffer 4. Timer cancel tasks input buffer 4. Same procedure in both for stopping the task. Well, I mean, it's you know, half a millisecond. It's gonna have a lot of serial prints. We're getting through most of the procedure. It's just for some reason it's multiple. The timer's like keeps going. We're not canceling the timer, so something's wrong with the way we're canceling the timer. No, it's half a second, I believe. I think. Yeah, it's half a second. I mean, maybe my math is wrong on a timer, but it does appear to be doing what it's supposed to. Timer of input buffer of 4, so it will be that position in the timer active is equal to 0. Is the timer active? If the timer active input buffer of 4 is equal to 1, then cancel the task's location input buffer of 4, and that references it by ID. Now, obviously, I should have put that to a variable, but we're just going to roll from there. So JDHD. Set software ID. I mean, face keyboard roll. My cat made my screen name, okay? I think our math is okay. I don't think you... Wait, where is our math? What happened to our math? Hold on, let me get this out of here. All the way down here. Time stored is time stored divided by the conversion factor, and the conversion factor is 308 or whatever, 328. 328. So. I don't get it. I don't know why we're not canceling the timer. Maybe our logic behind canceling the timer is wrong. I called the thing timer underscore active, right? Yeah. False, 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 false. Setting it to true when we set the thing. What's up, Groovy? Timer every time stored, time expired. Tasks packet ID. Oh, should packet ID be input buffer 4? Yeah, we're storing it in the wrong place. Still got a packet ID in here. That's our problem. Now we might have solved everything. So I'm talking about all the suggestions chat, and yet it was a different thing. This might do it. Do it. Where's my damn serial monitor? Hello? Okay. This is abusive. You're abusive. Oop. Come on, baby. This is looking a little bit more correct, maybe. Yeah, look. No more serial signals. Aha! Except we should have an O2 timer expiring more often. It hasn't set a new timer. It should have. Well, something happened, but our timers are working now. It stops timer 2, so where do we leave off? And it's recognized every code up until this. It's not responding anymore. What happened? Wait a minute. So something happened, but we did everything correctly. Look at this, chat. It's not spitting out any more code. Now, technically, it should be. So we're missing something. So our serial starts, we get a reset, we send the boot command. It tries to send bondable mode. It stores a bonding configuration. We need to get rid of this printout of the timer set, or maybe roll it into the printout. Let's roll it into the printout and we'll run it again. Where is the printout? These guys. Wait. Wait, this never... T... Oh, yeah, okay. Yeah, that's kind of breaking the flow of what we're looking at. Input buffer for... Then space T, print out the number, print line, there. So that'll just give us a proper printout. It sets the software timer, but then it unsets the timer by ID. So it's undoing timer 2, and we're doing what we were told. We're not doing anything. We're not, setting anything. So I think what happens now is we send it something. I think we send it something now. But let's get this, let's get this figured out first. And yeah, I probably should. I'm not gonna rewrite my code at this point to look better. Right now this code's a monster, and it's gonna end up being a monster in the Teensy 3.2. I don't care if you guys want to rewrite it or not. I won't run your code, but it could very much be simplified, especially given that there's like a whole class of IDs that we don't need to worry about. We could just print out the hex. We don't need the full verbose printout that we've implemented here. But yeah, let me upload this and we'll restart it again. And I think the next thing that we need to do is give it the ID of a connection. And we'll try that. It's uploaded. Serial started. Bada bing, bada bang, bada bingus. It didn't say it didn't tell us that it canceled, but it stopped ID 2. So timer ID expired number 2. Start discovery ID 2, stop ID 2, nothing. This is good. So we are literally exactly at the end of the amount of stored bytes that I got. We are down here at the 2.5 second capture line because we get timer received, and then I guess there's a stop. Here's the stop timer. And then it says that it received the stop timer. And then the module starts spitting out garbage that is ignored by the base station until it gets, I believe, a command that represents a connection, which is this one right here, 16.3D9, etc. So now we need to see what it says when we send this. So I need to copy this into a new Notepad++, paste, and then I replace the spaces with, what was it, comma, oh yeah, find and replace. Space with, yep, there it is, comma 0x, replace all. Need to add one up here. So this is what we need to send it. Now it's not, is that a 0A or is that just 1-6 off the bat? Weird that it's not a 0A. Excuse me. It should be a 2016.3, but yeah, I think what it's doing is it's scanning for Bluetooth devices, and it starts spitting out this very large packet that has to do with what Bluetooth devices are floating around, but the module doesn't care about the part that's controlling our wireless thing doesn't care. It doesn't care what's out there. It just cares if there's a connection. So now our code starts to take a bit of a turn. And in the send packets, I'm going to send it a constant byte. And this would be our device 1. And it's going to be a bunch of positions. We're going to see how big this thing is. Do a little bit of this, a little bit of that, a little bit of bingus, like that. Now, if this is 3-0, then it's D9. D9 is what? That's not 18. Let's just count them. 0, 1, 2. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Damn it. 13. 14, 15, 16, 17, 18, 19, 20, 21, 26. We'll see what D9 comes out to. Hex to decimal. D9. 217. All right, so that's not right. I think there might need to be a 20 in front of it. 2016 3. So that would be a 3-0. And then that would be, the length would be 16, 17, 18, 19, 20. I got 26. Hey, that's wrong. I need to decode this packet. I think we found it before. I don't think it's a 3-0. Let's check 3-0. Oh yeah, that's a custom-built power supply. It's one of those Chinese power supply modules with a very big power supply behind it. It can do 52 volts at a couple amps, more than a couple amps. And it can go lower and more amps and all that fun stuff. Okay, so we were able to find it in this. We need to figure out what the bytecode is for this packet. I think it's ignoring the A0, possibly. So if it's A016, and then something something, we can look up that something something. So it'd be A0 or 20 16 0300. I don't know if that's it, but let's try it. That would be this F. Well, we already know. Set data response. Advanced parameters. No. I mean, it's looking for a response right now, and we know what response to give it. I just need to get it into the right form, and we've already vetted this out. I just don't know. I didn't write down what it was, right? Did I write it down anywhere? I broke down all the other ones so that we'd understand exactly what we're dealing with, but I don't think I got the right one on this. Because we see these 16s here, and those actually contain the MAC address of the device. MIS data packets from above. Timer 2, set software timer. There's a lot of sorting out to do in this. My notes aren't exactly organized. And this is what we send when we press a key. We send a bunch of A0s. But we're close. We're so close to getting this thing into idle mode. We're so freaking close. Okay, boost converter. I don't know. It doesn't boost. It doesn't boost. Hey, thank you for the follows, by the way. It's a buck at least. I don't know. It's just a power supply module, so you can set it to all kinds of stuff. You do current limiting and specific voltages and things like that, but you need to provide it with more voltage. So I think mostly it's bucking. I don't think it's boosting at all. There's no big coils involved. 16 3D9. What is our command? It's not 0D9. I think there's internal stuff that determines, but there's also, I mean, this is 1D 2C blah 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 blah. That's the address of the Bluetooth device. So that would mean, I mean, are we sending a 2016? That would make it a 3-0. Where's our 3-0 at? 3-6, 3D, 3-1, 3-20, 3-17, 3-16, 3-C, 3-9, 3-5, 1B, 0E, 10. Come on, man, you can do this. 0F, 8, 4, 7. I really wish these were in like a respectable order. Command LGAP open. 1, 2, 3, 4 through 9 is the BD address and the address type. Response. Payload length. Generic access profile, ID, success, and then a handle. Only if the result code of the response is 0. So the result code is 0, and then it gives us a handle, 4, 5, and 6. 3, 3, I need to check to see if we have... We do have 3, 3. End procedure. Now, we have a different 3, 3 here, though. So we actually need to cater to this about whether it's a command or response, because we have the command end gap procedure that can either end stuff or it can give us a specific ID when we transmit that packet. Oh, man, I didn't record any of this, I don't think. I mean, we have over here, when I send the 16, that's all the way up here, or when I see the 16 sent, rather. Comms, comms, comms. This is the garbage that it spits out. It does have a form, but this is where it transmits the Bluetooth ID. But I'm not seeing what the response from the base station is. And this is where it assigns us an ID. So we need to print out, I guess, that response that it sends back. And so if it takes on the same form, we're in trouble. If it's a 2-0, we now need to do something different. Damn it. That we did not plan for. Why do you pop in and out of the Discord? Why do you do that? Let's see. 3, 3. But this time we have a command coming from the base station. Before, what was the... we don't know what the form was. We just got something that said gap end procedure. Let's see what that looks like in the log. Oh my god. 3-0. 3-0. Probably gets real angry at me. Maybe. 8294. Where are we doing the 3-3s? I mean, I don't see any other activity here. Well, then again, we don't see activity from the base station in this because we are just looking at the serial output that was between the module and the base station. So we don't get that reply. So we don't know what direction that end gap procedure is coming from. How do I build that in? I mean, I could make it, I could expand these and make it have the command type in there as well. Their stupid system is messing with me, man. Because look, here, we got 23.3. Wait, are there other types of commands, or am I high? Hold on, 23.3. 3.4, 3.8, 3F. These are not organized, and so it's very difficult to find what you're looking for if you're looking for the hex. That's 3.0. So this is the event LGAP scan response. This is the big packet, the 0B30. Well, actually, 16.30 is what we get. But that's the payload. So our payload is big. Oh, so it is an A0. Yeah. So 3.0 with a payload of A0. So this is the packet that we're trying to respond to. We're sending this. We're sending this, and we get what? Do we get a response? I think we do get a response above. Maybe we don't. Excuse me, maybe we don't. Connectable mode. These are the tables of values. So what does this, wait, what does this do then? If we send this over, I thought there would be a response that would tell us what the ID number is. You shouldn't get a response from an event. So if I send this, then I'm not going to get anything back. It'll just register the device. But I thought it was going to tell me what the ID was going to be. Well, let's send it this and see what happens. Maybe we'll go into, maybe it'll set timers and stuff and we can see if it doesn't, if our code doesn't recognize a packet, then we'll be able to see it on the printouts. That was the whole point of rebuilding the code, is that we now have a default state. So when we don't know any of the codes, then we'll print the entire packet out. In response to the LGAP scan. But it sends several times, and I don't know how to respond to that. If I just ignore it at first, and maybe we enumerate through a number of times, and then it'll just send that out. Send that out into the ether. Command LGAP start discovery. Where's my serial monitor? That's what contains all of our stuff. So here's what's going on. Command system reset, boot, bondable mode, bonding configuration, set software timer ID 2. Once that expires twice, it says gap end procedure. Then it sets timer 2 to half of that. So that's 150 milliseconds, I guess. Timer expire ID 2. Set connection parameters, expire, SM configure, 2, gap start discovery, timer 2 expires, and then it stopped ID number 2. So I guess when it starts discovery, I wonder if we just hit it with that packet. Command LGAP start discovery. And then we do sned, and then we send it. We send it our device 1, and we see what the reply is. So it's actually 0x 0a, or no, A0 0a, A0. And then what? 30 with length of length of 16. So technically it should be 20. So it's all the way out here. Do I have to truncate this? Because it should be 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh no, 1, 6 is different in hex. Oh, where's my window? Right. I think it's 18. It's 22. So it is 22, 3, 4, 5, 6. 4, 5, 6. Yeah. So it is 26, all right. Or should it be 27? No, it should be 26. That means that 0 at the end, I think, might be wrong. Yeah, it's weird that it deactivates the timer. Maybe it reactivates the timer when it gets event LGAP response. I don't know. But let's just immediately send it. Let's just send our device number 1. We can make our device number 2 be like 6969, but for now, we need to figure out if it's replying so we can code more stuff. I must code more things. So when we send event LGAP response, that's that. Serial print line I guess I'm doing R and T, but I put an S in one of them. I hate how French you've become. It's changed. This code has changed you. Device le registration. And then we don't need to clear the packet. The packet's already clear. So that's what we're doing. Device le registration. And then we see what it replies with and if all chaos breaks out. What we're eventually going to be able to do is when we get the device registered, it's going to be doing a timer that will periodically come in. So it's going to set a 1/3 of a second timer for us. So let's upload that code, and then we'll take a look at how it all goes down. Damn it. What did I do? What line is that? Oh, I forgot the end parenthesis on something. Got it there. Did that. Expected parenthesis. Oh, I. Bop. Try that. Too many. Yeah, that 0 at the end is just erroneous. Beep. Okay. Let's turn it on and see what happens. Oh, it's already on. Let's turn it off. Let it power down. And turn it back on. See what we get. Well, it sent the device to registration, and then the timer expired again, and then it sent it just stopped. So I really hope there's not another communication that has to happen from the base, from the module. Maybe if we wait a certain amount of time and then send the registration. There could be more stuff that we need to do in order to get it into the mode. Or it could be possible that we would be able to... Let me open up the Granite Devices software and see if we can fuck with it. That's going to be interesting. So, software, Simucube. Let's see if it registers, if it shows us the device at all. And it's just like, I don't know what's going on. Nope. Yeah, it's not registered yet. Connect to previously. Clear list, restart scan. Ah, look at that. Ha! So when we click the button here to restart the scan, it does device registration. I wonder if we wait a certain amount of time and we send it twice, if that'll do something. Let's try sending it twice in a short amount of time. Because that seems to be what it does in the procedure. That's cool that that works, though. Where are we? Because we know it's not sending additional stuff. We'll give it 10 milliseconds and then we'll send it again, which is pretty fast, but... And it's not looking for... I mean, I guess the serial buffer will store anything in that time. I'll close the software to be kind. We're getting there, though. Power it down. Give it a minute. Power it back on. Give it a minute. I like this close. Damn it, it didn't like it. Our timers are working, though. Our timers are working perfectly. It's weird, though, that it's not setting additional timers, and there's no, I guess, no additional serial information on the line. It says start the discovery. We say, hey, we got our registration right here, bud. Yeah, right. I would like to get to that point if this were going a little smoother. There's a bit of an unknown now. We don't know what's going on. And if our base station would send us a packet, we would be able to print it out. That should work. Any difference between the two packets? In our notes, remember we only have these captures. No, they're the same friggin' packet. And we know the contents of the packet too. We actually get a better capture of it down here. We've got it coming in like 50 times. I mean, we got that 00 in the end, but it's still, the length is 16, so that's the ID. So that'd be 1, 2, 3, or 0. Hold on. I gotta index. I gotta index in my brain. Index my brain. I gotta defragment my brain. Could you imagine if you could defrag your brain? It'd be awesome. You'd be like, whoa, I can access information again. This is the wrong data sheet. I had 2 copies of the data sheet open. Here we go. So this is the one we're looking at, and it goes until 14. Of course, we get 16. I just want to see how they're indexed. 9, 10, 11, 12, 13 goes to 12. Yeah, they're 0 indexed. Okay, so they're not 0 indexed in this. So if I go to my code, I really need to resolve this looking down at the monitor thing, because I look like I'm looking for a stain on my shirt. Our length is 16, which is 22, which is 26. So it would be 1. Oh, well, there it is. 26. It's right there. So that is the length. That 00 on the end is nothing. I don't know what 42 and 50 are doing, but we get that in multiple packets in a row. So what does it mean? Well, we know that we can transmit and receive from this thing. So it's a matter of telling it the right stuff at the right time. Now, we know that it repeats and repeats the discovery packet. Perhaps we wait until the timer stops and then we send it the packets. But I don't really know if that'll work. We could set it to just repeatedly send that packet. We could just set it to repeatedly send that packet. How am I going to do that? I mean, if I set up a new timer in this thing, or if I set it to do it like every loop, it'll send the timer just to like freaking hammer away at the machine. Let me think about this. If the timer is set to inactive, we unset it. I could set a secret timer 0 to resend the OK until we get a response, but I could keep sending it this time. How do I do this? All right, so we go to begin the discovery. Instead of doing that, we do a new thing. So we need to have a new variable. Bool. That's actually going to be bool discovery. Bool disco is equal to 0. And when bool disco is equal to 1, which means that if we get reset, we need to, well, we're not going to worry about that functionality yet. So bool discovery is equal to 1 when we get a begin discovery. right here. Disco is equal to 1. And then if disco is equal to 1, then we need a function. The function is going to be all the way up here, and it's going to be a bool. Hey, it me. And it's going to get nothing passed in, and it'll be just that. And then return 1 for now. And then down here, when disco is equal to 1, we can set up a timer that goes off every something something. And then we'll set it up as ID like 5. Hold on one sec. Let me implement this first. So tasks of 5, we'll just do, is equal to timer.every, and then the timer is going to be, let's make it 2000. That's 2 seconds. Let's make it every second. We'll just make it 1,000. And then we run hey it me. Was that lowercase h? Hey it me. Hey it me. And then we don't have any arguments to put in there. So we're setting up task 5, and then so we need to do, we'll set the, if we set it to, well, discovery is equal to 1 once, and it stays there. For now, we could just set it up like this, but we should probably register it as an active timer. Yeah, let's register it. So task active 5 is equal to 1, just in case. Is that what I called my array? Timer active, damn it. And what did I call the array? Did I call it tasks? Input buffer, timer, tasks. Okay. Timer active should probably be with the timing stuff. Okay, save that. Okay, so yeah, there's all kinds of other stuff out there, man. I use the regular Arduino IDE because that's what people will use when they start out, right? God, I'm slouching. Hold on. I have the back posture of a shrimp. Hello, it's me. I have the back posture of a shrimp when I stream. Yeah, I need to sit up a little bit more and get in frame. The only problem is I've got the steering wheel sitting right next to me, so it's kind of pushing me off to the side lately. All right, so the tasks, we got all our stuff. We've registered our timer. It looks like this thing is only using timer 2. So, I mean, I could probably, like, pare down the code a little bit and make it work a little better, but that's fine. So, we've got all the stuff going into the right stuff. We got all the references and things that we need. We're going to set it to send the connection event every second, and we'll see if maybe after those timers expire, it's capable of running. Now, we should probably have, like, an attempt countdown, but I want to get this thing working, and so we need that data. We need it to just run like 1 billion times. So, turn off the main event over here. Bop. That part of my stomach could hurt, probably because of tequila last night. That might have been it. All right, so tools. No, we don't need the tool to upload. We're just uploading this, and our code's going to work flawlessly from the get-go, right? We don't have anything to set discovery to 0 because we don't know what the response is going to be yet. So we're going to pretty much just... Oh, no! It automatically ran. Hold on. Why did that happen? If discovery is equal to 1, or if... I can just do if discovery. Oh, that was an equal... Okay, yeah, that's what happened. If disco. Now that'll fix it. Derp. It's like, hey, I'm here, hey. Okay, there. Now it's held at bay. All right, let's see. Timers. Ah! What the f... Hey, we got a new packet. Turn off auto scroll. Oh my god, what the hell was that? Why is it sending... I set it to send... Maybe it needs to be like 10,000? Maybe that's sending a little too often. It says 1 second, and it was just like... It sent it like a billion times. No. That should be every second. So what's going on there? What's going on with that? If this goes equal to 1, I need to do like that. I think that's what I need to do. I think it's running that over and over again. So every time we're setting it, it's like bop 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 bop, and it's just redoing it. So yeah, that's what it is. It's my return statements. Either way, we got a packet, and it keeps trying to stop the timer. 2831A. We are somewhere up here at the breakdown with the 2.5 seconds. So if we hammer it with 0300 16 packet thing, we get 2831A. So 31A. Length is 8. 0. No, 1, 2, 3, 4, 5, 6, 7, 8. So 31A. We saw that when we were bouncing through our 3s. So there's our 3, 0C. We're looking for 1A. 0B, 0A, 1, 3, 2, 6. Glad these are in order. 1A. Command Legap connect. Haha. Here we are. We're sorting through it now. So we can do a Command Legap connect. We can punch that up here. I'm gonna put it in here just so that we know what's what. But I can cancel every single one of these constant bytes. I don't need them. It's 12. And then we can take this stuff. We're doing it, chat. This is it. This is what I was talking about. And how awesome is it that our code worked, too? We were able to actually get and respond to signals that are coming in. So I'm going to make all these 0x's, and it's laborious and painful. Actually, we only need the 4. So that's our data. This is the coolest part of all of it, is when all of your systems and tools are starting to work together to bring you to the solution that you're trying to develop. This doesn't need to be 12, it needs to be 4, 0, 4. So we got a response back, and it's trying to set stuff. I think it's trying to tell us what our ID is. Because here's a 1A. Or no, it would be 11, wouldn't it? Where was our button press stuff? What did that look like? Sorry, that's not, I scrolled way away. Well, hold on. First, before we do that, we need to just make sure... 4 is bad. 4, and then down here, when we get that signal as 031A, so that would be Did I make it yet? Command the gap procedure, success, clear packet. Where is my start discovery? Sets discovery to 1, which sets the timer off. And then we have the one that undoes the timer. Case 0x031A. We probably sned a success. And then clear, we don't want to clear the packet yet. What I need to do is I need to, yeah, clear the timer is what I'm going to do. Yes. Give me a chance. We need to clear task 5 and then timer active is 0. How do I cancel timer? Do I have one in here that does that? I think I just need to unset the timer. I could set timer, no, but then I need to have it in the thing. I'm wondering if I could just call this and then make it unset the timer by resetting some of the bytes. That's a no, because we need to deal with the packet, so I need to manually unset this. So we need to unset our timer. Where were we typing? Where were we typing? There it is. Timer active 5 is 0, and then beep, there. Timer canceled. Where the hell were we? Timer cancel tasks of 5. And then that'll just unset our timer. And then we do stuff with the packet. So we need to figure out what we're doing with the packet now. We send a success, send an active, send a cancel. We have data that we need to process. What's that gonna look like? Well. What do we have here? Initiating PHY value. 031A, BD address of the device to connect to. So our Bluetooth device address is, where did I put it? It's in here. It's in here somewhere. I don't know where it is. BT. There it is. So this worksheet is crazy. This worksheet is just completely bonkers. Don't worry about the worksheet. So in little endian 84.2e, blah, 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 blah. And then it's registering it as device number 1. Ha ha ha, we got it. We got it. Ladies and gentlemen, we got them. We are going to need 2 more timers, actually. We're going to need a timer for it to give RSSI and battery updates. Coded or initial... What? PHY, what the hell is that? LGAP. 124. Type of PHY is used within the LE gap class. I don't even know what that is. Bluetooth LE gap. 1M, 2M, or coded. What is the PHY? I mean, we get an 01 from this, so I'm wondering if we register another device, if it'll set it as 02. So it's 20 is the, so it's a command. This is the length. This is the type of command, and it's just, you know, two bytes to the command. This is the device that it wants to connect to. Then we have, hold on, I gotta look it up. The address type of the device to connect to. What is that? 0. LGAP identify address. Use public or static device address or an identity address if privacy mode is enabled. I don't understand what that's trying to tell us, honestly. But that's what that's saying. And then it's 11 is initiating PHY. 4 is 1M. Sorry, 1 is 1M and 4 is coded. So we have 1M PHY. So 0, 0, 0, 1, 1M PHY. I don't know what that is. And then address type. And then it would be, what was it? 1, 2, 3, 4, 5 to 10. Sorry, this would be 11, maybe 12. That doesn't make sense. Wait, 0, 1, 2, 3, 4. It's 4. 0, 1, 2, 3, 4. 5, 6, 7, 8, 9, 4 to 9, and 10, 11. Huh. So, physical layer stack, like ISM band. Oh, okay. Okay, so it's radio stuff. Well, that doesn't give us an identification of what the buttons are doing at that point. So is there another packet we need to send it, or do we send it a button press now? Are we good to send it a button press, or do we start? Because I need to start 2 timers, and those 2 timers need to represent RSSI and battery level. And we could just set them as fixed, but it hasn't told us anything yet. We haven't gotten a reply from the base station that told us anything. So what do I need to do here? Now, if we run this code right now, what we'll be able to do is just see it stop giving garbage back, and it'll actually be able to cancel the task and do everything that it needs to do in order to sort of successfully run that part of the timing. I guess we should test it out. So I'll upload this. It'll upload. Little baby steps. We're taking little baby steps to get the remainder of the connection protocol done. And we're now in sort of the known area of the connection protocol. So we should know what kind of signals we need to send here in order to lock this down. I don't think you've seen me code before, Online Spirit. Power down, power up. Boop, 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 bop. We're sending multiple registrations, huh? Oh, I didn't put any prints in here. So we need to do serial.println r command le fuck off. Okay, let's upload that and see what it looks like. I'll make that the proper one in just a minute. Turn it off. Turn it on. See, the word send is protected within the compiler, so I have to make up something else. Oh my god, it hates us. Oh, it really hates us. Oh dear. Why does that keep sending then? Oh god, our serial's all polluted too. Turn that back off. What? Oh, we didn't clear. We didn't clear. That's why. That's what happens when we don't clear it. Yeah, no, we stuck it in a loop due to not clearing. All right, so what that's actually called is what was that one? It wasn't. Was it LGAP Connect? I guess it was. Or was it our device? It was it me, right? Yeah, that's the it me timer that we're setting up. So 31A, I think that's set. Yeah, 311A, yeah. Gap connect. Command gap connect. So instead of F off, call it that. We can be nice and leave a little commentary up there. And that should clear the packet and run once, and then we can see what happens from there. I think what needs to happen immediately after that is we need to send it the RSSI and stuff. Turn that on, see what happens. Oh, yeah, I need to look at serial. Boop. Why are we still sending registration? Whoops. I mean, we unset the timer. Timer active 5. If disco, then disco 0 again. And we're out of device registration. Unless it's not getting something that it likes. No, we're sending the registration over and over again. Why are we doing that? What do you, blah, blah, blah. I told you to stop. Timer cancel tasks of 5. Timer active 5 is equal to 0. Tasks of 5. We did everything for you. Why do you still run? 0 to 5, timer number. That's if this one expired. Send our device 1, sending device registration, return a 1. I mean, I could always have it return a 0 in order to stop it, but I should be able to stop it through this function. And we actually had the other function work perfectly fine too. Timer active is 0, timer cancel tasks. Where's our other cancel? It's all the way down here. Timer cancel tasks, input buffer of 4. That's in like a what is it, a byte array. So do I need to actually put in 0x05 in order to get it to stop properly? I don't think I do. I should reference that just fine. What have I done? Yeah, I don't understand. Why is it not stopping the timer? Timer response for, see what the timer number, send timer number, timer response rather. Our device 1, sending device registration, return of 1. That's when we get hey at me, and that's set by when we get command lid device, whatever. Start discovery, disco is equal to 1. Hey at me, disco is equal to 0. It won't run again unless discovery mode is re-enabled, right? Brule Story Co. See you in 5 minutes. All right, so let's see here. If we're in discovery mode, we set the timer active on the timer active array just in case shenanigans happen, right? Because every time we set a timer, I want to make sure that it's represented in the array so that we can check the array every time we set a timer, which I guess I'm not doing here. I should probably check to see whether or not the timer array has number 5 set before we set it again. We'll keep that feather in our back pocket for a little bit. But anyway, tasks, so when we set discovery, I don't need to do this multiple times, but I guess I just set up a flag so that if it puts us into discovery mode, it's going to reset that thing. So I set task of 05 equal to timer every second, which is approximately what we get. And it goes, hey at me, which just transmits our back. I'm going to die. God damn. I've had this like tight feeling just right here all day. I don't know what it is. So we set our hey at me, right? And so that transmits out our device discovery. It says, hey, here's this Bluetooth ID. Because like for some reason the base station is like fucks off and does whatever it wants. And the module is like, hey buddy, hey, listen, I've got some stuff going on here. Does it matter that it's 05 in the array accessor and not just 5? You know, you might be right about that. But wait, no, but it's in everything is I mean, I'm putting it all in 05. I have a tight feeling too. Mine's COVID. I don't know if that's COVID. It feels like an organ is doing weird stuff. It might just be coughing. For both of us actually, if you have COVID. I've had a cough for 2 weeks because I left my window open, and like everybody has this cough now. It sucks. I've tried not to transmit it. I was like isolating myself and stuff, but it's more of an allergen cough. It's like a post-nasal drip. You didn't see the 05 in other places. Yeah, I think you might be right, and that would have taken me 6 hours to solve. I'm a little weird about backseating. You guys should know. There's a lot of new people in here because I'm going a little later. If you already yelled at me, I'm sorry. Why not timer in instead of timer every? Because timer in does it once. I fucking hate you. I'm weird about backseating because sometimes you guys save me a lot of time, and sometimes you guys send me on wild goose chases in 5 different directions. But both of those inputs were valid. Timer in will set 1 timer every time this loop runs. And if we immediately set our Boolean to 0, oh no, that actually doesn't work. That doesn't work. Yeah, we need timer every because it needs to actually run a couple times because it needs to ping it a few times before it responds. So if we get the command to set discovery mode, we just set the timer to respond every X amount of time. We're just emulating the module, being like, hey bud, hey bud, hey bud. Mostly asking questions as a way to get my bearings. That's okay. I don't mean to be mean to people backseating. It's just I get a lot of odd responses, and you guys should expect that as an entertainer, I'm up here to be funny, and sometimes I will have to lay the smack down on people trying to backseat. Some people are actually mean about it, and it does get me in kind of a rut. But you guys have been good. You guys have been great. We're doing very complicated stuff, and that's why you guys have been good. Nobody understands what the fuck I'm doing. I really wish today was a much more accessible kind of coding. If we were setting off a relay every X amount of milliseconds, that would be neat. But unfortunately, we have to do this extremely complicated stuff in order to do the really cool stuff that'll allow me to beat Rabaz at the My Summer Car Rally preemptively, and so he can get mad at me. So anyway, you guys are my advanced way of cheating. Let's see if that does it. So we've changed 5 to 05. I don't know if that's going to make any difference. It might help us cancel the thing better. I mean, it's not like, where are we starting it? Well, we're starting it up here with 05s. I don't know if it'll make a difference. Let's just try it. We'll try it, and then in addition to that, no, we didn't do anything in addition to that. We haven't actually done anything. We actually just changed our 05s to 5s. If I put 0x05, maybe that would do it better, but I don't know. Let's just try it. It might not do anything. I don't understand why we're not able to cancel the tie. What are you talking about? Sned, not in the scope. You're not in the scope. Why is that suddenly out of scope? That don't make no sense. What am I trying to run it in? I might be in a, oh, I see. It's not in the scope of the, no, it was able to run this previously. Why is it suddenly hating me? Oh, is timer every a different command now, and so it fucks up? This is a weird error. Bop, bop, bop. Yeah, there it is. Timer.every, tasks of 5 is equal to timer.every, hey at me, and then we have no arguments to pass in there. Disco is equal to 0. I don't understand why the scope suddenly broke. Go back. I'm just gonna let it find the error for me. Timer number is equal, timer response of 4 is equal to the timer number. That's what we pass into time exp, and that sends the timer response, which, what is that doing? Why is that broken? Care. Timer response is for some reason broken. My send command is fine. I've got a semicolon in front of it, but not declared in the scope is suddenly a thing, which is odd because it wasn't pulling up an error before. That's not part of the code that we were really concerned with. I don't understand why it's suddenly broken. Full disco, brackets, return 1, all that stuff is fine. Hey at me is here. Why is this fucking it up? What did I do? I mean, we got like the stuff to run before too. I know, it's like, this is like the most blessed of the C++ errors that we've encountered. Oh! We have eliminated a bracket at the end of our loop. That's what it is. Our scope suddenly changed. That's what it was. I must have hit delete somewhere. Okay, so we're back. Let's see if it still continues to repeat over and over again. Stop it! Stop it! Stop it! Stop it! Stop doing that! No! What are you doing? Why? Maybe it's not giving us back the registration. I don't think it's canceling our timer. I don't think we're getting the right thing back. All right, stop scrolling. And you turn off. I don't need you. You turn off. Go away. Did we get SM configure? What are we looking for? We're looking for our proper response. For some reason, we didn't get the response. We got it before. Maybe we need to send it a little bit more often. I mean, we managed to get really far with this code today. I'm pretty happy about our progress. I got more in me, though. We're going to keep going. We're going to see. We're going to claw victory from the arms of defeat. We're gonna pry it out of its jaws. And then I'm going to go and sit in front of the computer catatonic for hours. after my brains have been completely squished dry. All right, so we are looking for what response are we getting in order to trigger our end of repetitions, right? And that would be legap connect. No, connect does timer cancel tasks of 5. Yeah, so we're looking for legap connect, not end procedure. That one just legap end procedure. We're looking for legap connect, which is 031A. So gap connect. Where's our serial monitor? Who's all we got? Well, there it is. The base station is asking to connect to that address. I'm gonna schedule a haircut at some point, guys. Jesus Christ. I'm like hiding behind my hair. It's like my hoodie. I can see. Get my 5 head going on, man. I'm solar powered. I need sun on this. All right, so sending device registration. This should be ending it. You remember that one? That was a post-pandemic. I had basically computer programmer ponytail. I was able to actually get a ponytail. And so I'd either wear a hat in order to keep the hair out of my eyes. I can actually almost do the computer programmer ponytail. I'm too fat for that. I'll look instant neckbeard. I was able to, I put on a hat to keep the hair out of my eyes, and everybody was a dick about it, even though most of the responses were, you look fine. And then there's the ones, you're wearing a hat. And it's like, yeah, I am. Like, why do you need to be like that? So we made a command for both the haircut and the hat. The hat just says, don't be a jerk. But the other one is, you got a haircut. Like, wow. But I have not got a haircut. Life cruel. So if we're setting our timer active to 0, we're canceling tasks, we're clearing the packet, we shouldn't be redoing... I mean, we cleared the packet. Why does it keep running our task? Does this need to be 4? That's probably what it is. Is it an array? No. We're specifically setting the array location of 5. How big is our array? We're setting a blank location in memory. It needs to be 4. We need to set location 4. Task number 4. Cancel number 4. Set number 4. Active number 4. I'm out of bounds. I know, I'm in memory that should not be altered. This is illegal. Let's try that. Maybe they'll cancel properly now. Yeah, why would it work? I could have been overwriting like some serious stuff. That was technically hacking. Beep, boop, beep. Let's go, buddy. Yes, yes, good, good, good. Haha! It helps if you're within your own array bounds, huh? What a pisser. Well, okay. So we gap connected. What does that mean for the Granite Devices controller? Hey, look at it. We got it. Oh shit. Oh, that's perfect. We did it. So now we need to send battery status and our SSI statuses. Look at that mofo. Hell yeah. Git commit. Control S, Control S, Control S. Oh man. So we got through the whole procedure. It's low energy. They put in all of the things. So low energy, but it looks like it's command le gap. So we've been saying that the whole time. Okay. Now, if we want to get silly with it, what I can do is I can throw in, do I know why? Yeah, you do. Because we're following the procedure, the handshake that is the predecessor to connecting a device. So now we're able to connect whatever the hell we want. And I could actually register a different device. Now, honestly, like making this into some kind of like a function would be nice, where it'll try to connect to a thing. I feel like we're getting closer and closer to needing like a procedural timer, like a task scheduler for this whole thing. But I'm gonna ignore that for now because I'm dumb. But we go into discovery mode. I wonder if we can, let's do something silly. Let's do this. Let's do, I mean, I could send it like 2 packets. Our device 2. Our device 2. And obviously, the Bluetooth address for it has to be 69 69 69 69 69 69. Save that. Let's see what happens. What is it going to do when we try to connect that? The only thing is that we're not printing out the I would like to connect to this device thing. So I don't know if it's, I don't know where or if it assigns it a number 2 versus a number 0 or 1. So we don't know exactly how it's addressing new Bluetooth devices, and this might trigger a whole mess of packets that we don't know what's going to happen. Let's try, instead of connecting device 1, we're going to just connect device 2, and we'll see what happens. So me up here, we send device 2. I was going to try to connect 2 modules at once, but let's just see what happens when we send module 2 and see if the controller wants to connect to that. I might have to hit the button to make it scan and connect, but let's just see what happens. We'll take it one step at a time. And hopefully this reveals some new data. Otherwise, I'm going to have a shit fit, and then I'm going to ban Cannibal Jesus forever. Forever. All right, let's turn it up. It's not each button, it's each 24 buttons is a new Bluetooth device, yeah. It looks like it connected. So now Granite devices, Simucube. It's not looking good for me. Let's see. Funny sex number. Yeah, so we can just connect stuff. How cool is that? So we can have it run through a list of devices until they're all connected. Look at that. Now, I don't know if that's registered or not, and we need to start... Hold on. Once we're connected, we need to start sending... I think we need to kick it off with either a button press, or we need to kick it off with like an RSSI and a Bluetooth packet. So we need to set up 2 timers in addition to the ones that we already have. Fatanon! Oh my god! 38 months at tier 3. Holy shit, dude. That's like, each tier 3 is like 72 tier 1 subscriptions, which is insane. Thank you for 5,000. If I do the math in my head, that's 9,823 tier 1 subs that you're responsible for. Thank you. Finally made a stream. Oh yeah, you've been busy, man. Well, we got funny sex number to register as the MAC address, so we've made a lot of really good progress today. My code is abysmal because it's been sort of tacked on piece by piece, and we're using a timer library that some guy made, and it's like a beast. It's a total mess. I probably want to go for like another hour, just because that cramp right here is kind of really bothering me. But we've made some amazing progress. Let us set up 2 more timers. We need an RSSI timer and we need a battery timer just to keep these devices alive. We could just set it to whatever number. We just need the Bluetooth address from whatever devices we are registering. So what form is that gonna take? I think we need to just go through it the way we do normally. Resharding a Redis cluster that has 400 gigabytes of memory of data, and I had to do it live. I don't even know what that is. It sounds abysmal. Funny sex number. All right, so let's see if we can get the devices to report battery and RSSI. So we need a battery timer and an RSSI timer per device. How many timers are we going to need? We're going to need like 5 timers on this thing. Depending on how many devices I want to connect, we need to hook up like a bunch of different timers, huh? Maybe 2 timers. We send, don't care. The module, the base station does not reply to the little packets that we send. So if we just send packet, let's see if that works. So let's set up a third, the hey at me timer. No, we're not going to use hey at me. This is going to be bool bat and then bool RSSI. So battery packet timer. And then this is going to be RSSI packet timer. And now we have our battery and our RSSI packet. So R device 1, R device 2. R device RSSI 1. Actually, we'll just do RSSI packet, and we'll replace what we need to replace with the right values. And then const byte, and then that's battery packet. Actually, that can't be a constant because we need to replace the values with the values of our stuff, I think. We can't do that with a constant. We'd have to like stop it from printing and then print the right thing in there. Or we can just we'll take these as variables. They're no longer constants. And that way we can just replace what we need in there with the right stuff. Because we need most of the form, and then we'll replace the device address, which I don't know how to really get to, because I didn't see any differentiation in. Maybe when we register 6969, we should take a look at what value it gives for the what that response is from the device connect. Yeah, maybe we need to do that. Here, let me code that up real quick, because we need to know what it's going to see as a button press from funny sex number. So that code shouldn't affect anything. So I'm going to hit save, and then we go to what is it? The print. No, it's the command legap connect. Yeah, command legap connect. And what we need to do is print Actually, I just need to do I have a packet printer? No, that only writes it to serial 2. Oh no, print packet? Yeah, print packet. So I can just do that, and then we can take a look at what that packet looks like when funny sex number connects. Upload. Now that bird's back, the one that just goes, "Ugh." I think it might be a squirrel that makes that noise. They just get out there and they go, "Ugh." Beep bop boop, beep bop beep bop, boop boop bop. Funny sex number. 0001. The other one 100, or was that also 0001? I think that was 0001. So we don't get a differentiation there, do we? 031A, and then there's the MAC address, and then it wants 01. Go back to the data sheet on that one. Address type of the device to connect to, and then the initialing PHY value. Oh, we might not be responding again. We might need to respond to that. Handle will be assigned to the connection after the connection is established. This handle is valid only if the result of this response is 0. Or are we getting a response? Wait, which direction are we in here? The command is sent to connect to funny sex number, and then we need to respond with a result code. response, payload length, generic access profile. There's a 23.3 in here that we need to find. I guess that's why connection is not established there. So what do we have in our notes then? So we never saw this, but there should be a 23.3 somewhere in here that I guess I never got. 28.3. So this is what we get sent. 31A. There should be a 20-something 3.3. Hold on, I'm gonna cough. There's like a handshake that we need to do. I don't think I got the raw values in here. These are all A0, but then some of them have like a mid-20. Like we should get it somewhere in here. But then I just get a button packet sent immediately. I didn't see any more of the handshake going on. So there's, I don't know. I thought there would be more of a handshake, but we didn't receive it when we sniffed out the packets. There's a 23.9, or an A039. 22.99. 39 something or other. I think there's other stuff going on in here that we don't really know. 9.4, 111. Any 20s in 22.9. This is a 9.5. 9.5 again. 22.81. What were we looking for? We were looking for 3.3. We're getting like 8.3 and stuff. Well, there's 8.3. 1A00. And then it's got a 1 like A, which doesn't make any sense, or a DA. Oh, sorry, those are 3.1. Those aren't 3.3. Wait, 3.1A. 3.1. It's different. Okay, hold on. I'm just trying to get my bearings here. 8.0. 8.1. Anything following a 20, I'm looking for. And then the normal handshake comes in. I think there's a series of commands that I don't know what they do that may or may not. How are you responding to the connect command? I think we just do a generic response. So I think the generic response needs to be a little bit more complicated. I think maybe we need to. I was going to just send it the battery status in RSSI, and maybe it would actually work properly. Like 9.9. I'm not seeing 3.3 anywhere is what I'm looking at. Or 3.1A. This is, so by the way, this is what we captured using a serial sniffer. So there's an event generated from the connection. Eventlet connection opened. Open and parameter. Ugh. I hope we don't need this. It's whether the device is already bonded and whether the role of the Bluetooth device is a slave or master. 0B, sorry, 80. Well, there it is. There it is. It's right here. We have 8 zeros in here. This is why we saved all this data, by the way. 2299, 2299. There's an 80 somewhere in here. I remember seeing 97. 2297. Now this is the base station replying, so maybe this is no. This is the module talking. Okay, hold on. 95, 96. That's 83, but we already know that response, I think. 8-1. We're off by 1. Oh my god. This may be where we have to take a break. This, I think we're at the point of self-destruction. And I may need to just circle back around and think about what we're doing. But I mean, we're flying along. We're really getting to the bottom of this right now. We were able to register into the Granite Devices software the device. I mean, it might stand to reason that we just start sending it the button press packets and it'll respond to that, depending, like without doing the entire handshake. Let's try, okay, here we go. Let's try a singular delay event and we can send a button press and a button lift. Now, funny sex number device registration isn't gonna fly. We're not really gonna be connected, but let's send a button down, button up event as we observed it from the other device, from our actual Bluetooth, from our number one, right? The one that actually has an address. And I think it's not gonna work. I think it's not gonna, signal strength is at 100 though. Let's see. So I just wanna try this for the sake of just dicking around. So command gap connect. What can we do? When we stop this timer, no. What we want is once we've connected, here we're printing whatever packet it's trying to. What did we get for that, by the way? We got like some packet? Oh yeah, we got this. I'm just gonna copy that over to our note sheet. And so at this point, where are we in the connection? We're beep, 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 beep. We're right here. And what did we send? What was the last thing we sent? Or maybe received? That's in here. Sorry, I'm trying to keep this. Trying to keep everything in order so that I have notes that I can call upon during my 3D printing tomorrow. Because I'm going to get that red filament, that deep red filament that'll properly represent AMD's. I don't know, they decided to go with red. I'm not a big red person. I'm not huge on reds, but I think it'll look good on the computer. I need a dark color to offset the anodization and stuff. And if it goes with the look of the AMD hardware, that's okay. So I'm going to go with a deep red for the whole thing. That filament gets here tomorrow. I got the ABS that Wexo sent. I would like to try that for some stuff, but I'm not going to print a black computer case. It's too edgy. So, so what is it? Hammer it with that. We get that. Then we send the device registration. And we get that. I'm going to save that file. 01. The other one that we got, I don't think we have a... Oh yeah, there it is, 01. So we get the same packet back twice. So we're not registered yet. I don't think we have the information to send back a button push or a button lift. I don't know. Let's just send like a button down and a button up. And I'll just call them BTN down. And we'll make them constants. Button down and button up. 0x this whole thing, huh? 0x, 0x, 0x. Luckily, I can just do one and then modify the other one. And then when we actually do this with the LIN bus stuff, the LIN bus will just compare to what we sent last time. And then if there's a change, we'll send this out. We can just replace the hexadecimal area. And it doesn't matter if we're little endian or not. Boop. Oops. Boop. Boop. God damn, this sucks. I should have done the Notepad++ thing. Whatever. Whatever. We're making progress. We're getting there. What I basically want to do is just start sending this over and over again and seeing if we get a response to the button being pressed. All right. How big is this? 1, 2, 3, 4, 5, 6, 7, 10, 11, 15. And then I'm going to take this whole thing. And in fact, all we need to do is zero out that guy right there. And that represents button number 2 or button number 1. Remember, little endian, everything after that 04 we're flipping. And so it's all zeros until the one button that's pressed. That's our packet. And we also need to actually we need to properly end all of these statements. Otherwise, all hell breaks loose. But for some reason, and we're not totally sure about this, I guess 9.4, maybe we are sure about this, but we have like a big payload in here, and the big payload appears to have other fields that represent the size of things that are going on. So we don't really know what's going on there. It's strange. But button down and button up, what I'd like to do is set a... We need kind of like a sequence of events, don't we? Oh, how do I do that? Let's see. I can set up a timer. I could set timer 5 to do that. Once we cancel the timers, let me just try to hammer it. We'll just do this in the dumbest way possible, right? I'll set up a timer and just make it do stupid button stuff. Stupid button stuff. So what I'll do is I'll create a new function up here. It's just going to be your dumb button. So we'll just make bool dumb but, and then that's going to, nope, that's going to start a timer. Oh, no, that's not going to start a timer. That actually sends sned but down. Oh, no, that's not what I called it, is it? btndn. Button down. Actually, I could just do one packet. Yeah, I should just do one. It should just be the button packet. And that'll set it to 0. And then O2 is 0, 0. And the location that we want to alter in order to press the button is, well, 14, 13, 12, 11. And it's not a constant. We want to alter 11. So when this is called, if btn of 11 is equal to 0, button of 11 is equal to 1. Hello, cough. How are you? Else button of 11 is equal to 0. And then send, every time this is called, it's going to send a new thing. Send button. Done. I'm so smart. Okay, send button. So now we just call that periodically because we have registered our device. So once we send funny sex number over and we get that verification, where are we doing that? We end our thing. Discovery is equal to 1. That's start discovery. Command gap connect. Cancel tasks for timer dot. Well, actually, button test. We run button test. So we'll just like make a stupid thing down here. Void button test. And what that's gonna do, that's gonna what is that gonna do? Timer.every 1000 and then it's, what did I call my function? what a name thing did I call my function again? Dumb butt. And which timer are we gonna set that as? I guess we'll set it as timer active timer 5. I'm just gonna do that to be kind. And then timer. Shit, what was that thing called? Blah, 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 blah. Tasks. That's just so we can stop it again if we feel like it. We're not going to stop this one again. We're just going to let it run infinitely just to see if it likes it or not. But, you know, if we register it properly, then we can. I mean, I'll probably have to make another timer as well, or like 2 more, so that we have the 5 available, even though they're not being used, and then we have a couple on the end that'll do RSSI and battery updates. So timer every 1000, it does dumb butt, and then if we feel like stopping it, at least we registered it properly. In the 5th location, which is kind of like an extra one that we use just for weird tasks like timing various packets that need to go in. All right, let's give this a shot. I mean, we're looking for behavior from the Granite devices controller and not the serial controller now. So this is gonna get weird. Things are gonna get hinky. We shard up our serial, but we're not getting any responses, so I'm gonna turn this off. Is that OOB or did you add a 6th timer? Oh, that should be 4. It's out of bounds. Shit. I keep trying to push the boundaries here. We need to add that 6th timer because I'll use 5 and 6 and I'll turn 5 into either RSSI or battery, and then 6 can become either RSSI or battery, whichever's left, right? So, all right, upload. No, not very. Upload. So yeah, we're just gonna see if every second we get a button press or not. It probably won't. Oh wait, we didn't. Hold on. We got to register the other device again because 6969 isn't even registered. I think there's more of a handshake that we need to uncover there, which is an unfortunate amount of work that we need to do. But I think we're very close to getting where the base station tells us what ID to respond with. But I want to keep it within what we know. So I want to respond and look for the thingy. We need cinnamon. Let's see, where is that? Up here? Yeah, we want to respond with device 1 instead of funny sex number device. Okay, so we're ready to go. Turn on the controller. We're making a lot of progress, guys. I hope you appreciate how much we're getting done here. That's a new one. Wait, why did that print? Wait, why did that print? That shouldn't have printed. We've identified that packet now. Huh. It should be 8.1, right? 8.3 3.1a. Don't we have 3.1a? No, we don't have 3.1a. Yeah, we do. 3.1a. Oh, 3.1a. Oh, I made it print the packet. That's right. Yeah, that was me. That's on me. All right, so let's take a look at what Granite devices say. Connecting. Darn. Well, okay, so it starts, the initial process has started. We need to do more of a handshake. So I need to look into that a little bit more. I need to look into that. See, we've got one button that's pressed, and that's actually a default configuration from our controller that I'll need to unset in the future. See how that one's pressed down? That's just there. That's just the way it functions. I think that one is a logic-based button, depending on where the sequential shifter is. But we're not pressing and unpressing a button here. And we do have a signal that's coming through. Yeah, we do have a signal that's coming through. Curses. We'll get it. We'll get it. I'm going to save everything where it is. I'm going to throw this up on the internet, on my Discord. So it's not necessary. I mean, it's technically that's the internet, but I'll throw it up on the Discord. And then we're going to work with it more in the near future. Monday, if I can help it, should be a computer work day. But if I can't get all of my 3D prints done in time, sorry, Tuesday. Tuesday will be a computer build day, unless I can't do all of my parts in time. All my 3D printing collapses on me, and I'm buried under there forever. The cast of a bother you. If I don't get the 3D prints done, we can work on this more on Tuesday. Otherwise, we'll push it to Thursday, because the computer's not going to take all that long. This is cool. Damn it, I hit verify. This is cool. We're making great progress. We just need that last little bit of handshake that I technically probably have captured, but is not quite there. So let me give you guys the code. Look at that. Look at that beautiful, beautiful boot sequence. It's wonderful. Okay, and then I'm gonna go to, oh, that is not, so we were using this library here, but I need to go to the button flipper, and then Discord, and I will delete what was there. I will drag the button flipper into here and update that. And I will be editing that code. I'm going to be working on that tomorrow and Monday. Tomorrow and Monday, in between prints, because there's, Lord knows there's nothing to do in between prints. You might as well code software. Ooh. So I'm going to work on that. You guys can catch me on Discord. You guys know who I am. Yeah, you guys have a great weekend and everything. If I do the end command right now, it's possible that Octodad did not set it. It's probably going to say 3 days ago. But the important part, oh no, 1 day, 17 hours. Who are you? You know what? I forgot. I was hoping you guys would tell me. We made amazing progress. We were at the point where we're starting to figure out how to register an individual device. And so I think we'll be able to do that pretty well. It kills me because I'm pretty sure the Granite Devices controller probably has the ability to just get a serial packet out of the blue and register that as a button press. But we'll never know. We don't know how that works. So we have to pretend, we have to do this whole song and dance to pretend that we are a wireless module. Now, we should have captured the packets that will take us from where we are to where we're going. Why is Robbo streaming Long Drive? Because he's addicted to the Warhammer game, and so that's had him. Oh, I got a cold sore on my tongue. A cold sore on my tongue. I'm affecting the way I talk suddenly. Oh man, that probably means I'm a little too active on streaming. But next week is weird. There may or may not be a canceled stream on Friday. We'll see what happens. Saturday is not happening next week, so maybe I'll do a gaming stream in between there because I don't want to wait a whole week until I do anything. And I may or may not have a brand new computer. And then the week after that, I'm going to be punching the streaming hard, so I'll be around. Anyway, I will catch you guys later. Let's get to the bottom of this thing. We're gonna continue work on it. And until then, take care.